Consider the solid objects around you right now, the chair beneath you, the device you're holding, even your own body itself, all of it feeling remarkably substantial and real to your touch. Yet the scientific truth that emerges when we examine matter at the atomic level is so counterintuitive that it seems almost impossible to fully accept despite its overwhelming empirical verification. Atoms, the fundamental building blocks of all physical matter, are composed primarily of empty space, with electrons orbiting a nucleus that occupies only an infinitesimally small fraction of the atom's total volume, and this same architectural principle scales upward to comprise every single object in existence, meaning that the density you perceive, the resistance you feel when you push against something, is largely an illusion created by electromagnetic forces rather than actual physical substance. If you were to remove all the empty space from the atoms that make up your entire body, compressing only the actual matter itself without any of the void between nuclear particles, you would shrink down to something approximately the size of a grain of salt, yet you would retain the same mass you have now, a fact so profoundly strange that it challenges our most basic understanding of reality and physical existence. The reason this persists in our collective consciousness as surprising rather than understood is rooted in the scale limitations of human perception. Our sensory systems evolved to interact with objects measured in centimeters and meters, not nanometers and subatomic distances, and therefore we developed an intuitive sense that solid things are actually solid, that touching something means particles are in contact with particles, when in reality contact is always mediated by electromagnetic repulsion between electron clouds, never actual collision between matter itself. Every banana you have ever eaten, every one you might eat tomorrow, contains radioactive potassium, a naturally occurring isotope called potassium-40 that emits radiation in measurable quantities, a fact that seems to contradict our everyday understanding of fruit as something wholesome and entirely safe for consumption. The reason bananas contain this radioactive element is straightforward in its scientific explanation. Potassium is an essential mineral that plants absorb from soil during their growth cycle, and a small but consistent fraction of naturally occurring potassium exists in this radioactive form throughout the Earth's crust and in virtually all living organisms. When you consume a banana, you are ingesting approximately 120 becquerels of radiation, a unit of measurement that describes the rate at which radioactive atoms decay, and this amount is entirely harmless because the quantity is so minuscule and the exposure so brief that your body processes and eliminates the potassium before any cellular damage could possibly occur. The psychological mechanism that makes this fact so difficult to accept stems from our cultural association between the word radioactive and catastrophic harm, an association reinforced by decades of media coverage depicting nuclear accidents and weapons, creating a mental shortcut where any mention of radiation triggers anxiety and fear regardless of dosage or context. Yet the human body has evolved alongside natural background radiation for millions of years, and we are constantly exposed to radioactive elements from cosmic rays, geological sources, and yes, from the foods we eat, an exposure so normalized that we have developed biological mechanisms to handle it without consequence. The persistence of this cognitive dissonance reveals how our rational understanding of scientific facts often fails to override our emotional responses to certain vocabulary and how we can simultaneo. When we consider the timeline of life on Earth, we typically envision trees as ancient organisms that have stood rooted in soil for countless millennia, representing the very essence of enduring nature and primordial existence. Yet the reality is that sharks predate trees by an almost incomprehensible margin of time that stretches back roughly 400 million years. Sharks emerged in the oceans during the Ordovician period, long before the continents were arranged as we know them today, evolving into increasingly sophisticated predators that would come to dominate aquatic ecosystems across the globe. While trees, those towering monuments we associate with ancient forests and environmental permanence, did not begin to colonize the land until approximately 380 million years ago, making them relative newcomers in the grand chronology of complex life. This temporal inversion of our expectations stems from a fundamental cognitive bias in how humans process evolutionary history, as we tend to categorize organisms based on their visible presence in our contemporary world rather than their actual origins, meaning that because we see forests surrounding us now and perceive trees as unchanging fixtures of the landscape, our minds automatically assign them greater antiquity than they actually possess. The ocean, conversely, exists somewhat removed from our daily terrestrial experience, and the creatures within it feel more mysterious and foreign to us. So even though sharks have been silently perfecting their body plan and hunting strategies for 400 million years, we somehow fail to recognize them as the true veterans of life's long history. This disconnect persists in our cultural consciousness despite the widespread availability of scientific information, suggesting that our intuitions about age and permanence are bound more tightly to visibility and familiarity than to actual evidence, and we continue to associate. Imagine filling two identical containers with water, one filled with hot water fresh from the kettle and another filled with cold water from the tap, and then placing both into a freezer at the same temperature. According to classical physics and our everyday intuition, the cold water should solidify first, yet remarkably, the hot water often freezes before it, a phenomenon that has puzzled scientists and observers for centuries and continues to challenge our fundamental understanding of thermodynamics. This counterintuitive occurrence is known as the Mpemba effect, named after Erasto Mpemba, a Tanzanian student who documented the observation in the 1960s, though the phenomenon had been noted by Aristotle himself over 2,000 years prior. The scientific community has proposed several mechanisms that might explain this bewildering behavior, including the possibility that hot water experiences greater evaporation as it cools, thereby reducing its mass and requiring less energy to complete the freezing process, or that convection currents in hot water distribute heat more efficiently throughout the container, paradoxically accelerating the cooling rate at certain stages. Another theory suggests that hydrogen bonding in water molecules behaves differently when water begins at higher temperatures, potentially altering the crystalline structure that forms during freezing and making the transition more energetically favorable. Despite decades of rigorous experimentation and theoretical analysis, scientists have never achieved complete consensus on which mechanism primarily drives this effect, as different experimental conditions seem to produce varying results, suggesting that multiple factors may contribute simultaneously depending on the specific properties of the containers, the precise starting temperatures, the surrounding environment, and even the mineral content of the water itself. Consider the archaeological evidence that archaeologists have discovered in Egyptian tombs, where pots of honey have been excavated from burial chambers that date back more than 3,000 years. And when these containers are opened by modern researchers, the honey inside remains perfectly edible, completely preserved, and entirely unchanged despite the passage of millennia and the exposure to countless environmental conditions that would have destroyed almost any other food substance known to humanity. This remarkable property stems from the unique chemical composition of honey, which contains an extraordinarily low moisture content of approximately 17 to 18%, creating an environment so inhospitable to bacterial growth and fungal proliferation that microorganisms simply cannot survive or reproduce within it, regardless of how long the honey is stored or what circumstances surround it. Additionally, honey possesses a naturally acidic pH level that further inhibits the growth of pathogens, and it contains hydrogen peroxide, which forms slowly over time and acts as a natural preservative that actively prevents decomposition and spoilage from occurring through any mechanism whatsoever. The process works through a principle called osmosis, whereby the low water content causes any bacteria or mold spores that might accidentally enter the honey to lose their internal moisture and desiccate completely, making it impossible for them to metabolize or multiply or cause any degradation of the honey itself. What makes this phenomenon particularly striking is that honey is the only common food substance that possesses this virtually unlimited shelf life, standing in stark contrast to nearly everything else we consume. And yet we have largely normalized this astonishing fact to the point where we rarely pause to consider how profoundly improbable it truly is that a sweet substance made from flower nectar could maintain perfect pursuit. When you consider the vast expanse of human history stretching backward through time, an astonishing temporal paradox emerges that challenges our intuitive sense of chronological distance. Cleopatra VII, the last active pharaoh of Ptolemaic Egypt who ruled around 51 BCE, lived closer in time to the invention of the iPhone in 2007 than she did to the construction of the Great Pyramid of Giza, which was completed approximately 2,360 years before her reign began. This means that more than 2,000 years separated Cleopatra from the pyramids that defined her civilization, and that she would have regarded as ancient monuments herself. Yet only 2,058 years separate her from the moment Steve Jobs unveiled the first-generation touchscreen device that would revolutionize modern communication and technology. The human mind struggles to internalize this comparison because our evolutionary psychology developed to comprehend short-term, immediate timescales rather than millennia-spanning intervals that dwarf individual lifespans by orders of magnitude. We tend to compress distant historical periods into vague categories of pastness without accurately mapping the actual durations involved, treating ancient Egypt as a monolithic concept rather than understanding it as a civilization that persisted across roughly 3,000 years of recorded history, making it vastly longer than the entire span from the fall of Rome to the present day. This cognitive limitation causes us to feel intuitively closer to figures like Cleopatra than the mathematics actually suggests, because we lack evolved mechanisms for truly grasping such enormous temporal distances in our daily cognition. When we think about the great civilizations of history, we often arrange them in our minds as though they existed in separate temporal spheres, each occupying its own era of the world, yet the University of Oxford was founded in 1184, while the Aztec Empire would not rise to prominence for another 244 years, not establishing Tenochtitlan as their great capital until 1325. Which means that by the time the Aztecs were building their magnificent floating gardens and creating one of the world's most advanced urban centers, Oxford had already been teaching theology, logic, and natural philosophy for a century and a half, producing generations of scholars and thinkers whose works were being copied and distributed across Europe long before Montezuma would ascend to the Aztec throne. This chronological reality surprises us because we have internalized a mental model of the world divided into hemispheres and eras, where European medieval history and the rise of Mesoamerican civilizations feel as though they were happening in entirely different time periods, when in fact they were unfolding simultaneously, separated only by vast oceans. And what makes this particular fact so resistant to our intuitive understanding is that we tend to think of the Aztecs as representing some ancient civilization lost to time, when in truth their civilization was developing at precisely the same moment that Oxford was becoming one of Europe's most prestigious intellectual centers, both institutions thriving in the 1400s and 1500s, contemporaries across the world. Existing in the same century, though separated by continents and entirely unaware of one another's existence. And this collision of our temporal intuitions with historical fact reveals how our brains organize history not by actual chronology, but by the cultural narratives we have absorbed, by the books we have read, and the stories we. Deep within the atmosphere of Neptune, one of the most distant planets in our solar system, scientists have discovered evidence of a phenomenon so extraordinary that it challenges our conventional understanding of planetary weather patterns and the behavior of matter under extreme conditions. In the upper atmosphere of this ice giant, where temperatures plummet to approximately -230 degrees Celsius and atmospheric pressures reach levels incomprehensibly higher than anything we experience on Earth, methane molecules are constantly being broken down by ultraviolet radiation from the distant sun. As these methane molecules fragment under such intense conditions, the carbon atoms they release are exposed to the escalating pressure and heat as they descend deeper into Neptune's atmosphere, and this process causes the carbon to crystallize and compress into diamond structures, forming what scientists refer to as diamond rain. These diamonds, ranging from small particles to potentially large crystals, fall continuously through Neptune's turbulent cloud layers in a perpetual cycle that has likely been occurring for billions of years, creating an almost incomprehensibly vast quantity of diamonds within this distant world. The psychological mechanism that makes this phenomenon so difficult to accept is rooted in our terrestrial perspective, where diamonds represent the rarest and most precious of gemstones, something so valuable that it defines luxury and permanence in human culture. Yet here we find diamonds forming as commonplace weather events on a planet we can barely perceive with our own eyes. We have normalized the scarcity of diamonds on Earth through centuries of marketing and cultural significance. Yet the universe operates under entirely different rules, where the specific conditions that create diamonds exist in abundance throughout the cosmos, rendering our precious gems merely the mundane byproducts of planetary ATM. Consider the peculiar reality of Venus, our neighboring planet shrouded in thick clouds and extreme heat, where a single rotation on its axis takes approximately 243 Earth days to complete, yet the planet orbits the Sun in only 225 Earth days, meaning that a Venusian day is actually longer than a Venusian year. This counterintuitive phenomenon defies our everyday terrestrial experience, where the concept of a day passing within a year is so fundamental to our understanding of planetary motion that we rarely question it, assuming all worlds function under similar celestial mechanics. The explanation for this remarkable situation lies in Venus's extraordinarily slow rotation and its relatively close proximity to the Sun, combined with orbital mechanics that were likely influenced by massive collisions or gravitational interactions early in the solar system's formation, events that may have altered the planet's rotational speed to its current leisurely pace. What makes this fact particularly difficult for our minds to fully grasp is that our brains have evolved on Earth, where the relationship between day length and year length follows a logical progression, where days are invariably shorter than years by a factor of hundreds, creating an intuitive framework that we project onto all celestial bodies despite their vastly different conditions and histories. Yet despite the abundance of astronomical data confirming this reality, and despite centuries of observation and modern space probes providing detailed measurements of Venus's rotation and orbital periods, this fact remains largely absent from popular consciousness, relegated to trivia and scientific discussions, while our collective imagination continues to picture planets as functioning similarly to Earth. A profound disconnect between what we know scientifically and what we understand viscerally about the cosmos surrounding us. Deep within the coral reefs and coastal waters of the Indo-Pacific region lives one of nature's most extraordinary visual creatures, the mantis shrimp, which possesses the remarkable ability to see not merely the colors that humans perceive, but rather 16 distinct types of color receptors in its eyes, compared to the 3 that humans possess. While human vision relies on red, green, and blue cone cells to construct our entire visible world, the mantis shrimp has evolved a far more complex visual system with multiple types of photoreceptors distributed across 12 to 16 different channels depending on the species, allowing these small crustaceans to detect wavelengths of light ranging from deep ultraviolet through visible spectrum into polarized light and even into the infrared range. This extraordinary capability means that mantis shrimp perceive colors in a way that is fundamentally incomprehensible to the human mind, seeing distinctions and variations in light that exist completely beyond our biological capacity to imagine or visualize. The mechanism behind this remarkable vision involves highly specialized compound eyes, each containing thousands of tiny lenses that work in conjunction with specialized photoreceptor cells arranged in distinctive rows and bands across the eye's structure, creating a system so efficient that the mantis shrimp can detect even the slightest variations in color and light polarization with what researchers believe is extraordinary precision and speed. Yet despite possessing this seemingly superior visual system, scientists have discovered through careful behavioral studies that mantis shrimp do not necessarily have superior color discrimination abilities compared to humans in practical terms, suggesting that their expanded color perception may serve very specialized evolutionary purposes related to rapid predation, territorial signaling, or communication within their complex social structure. Consider the anatomy of the octopus, a creature that dwells in the deep ocean waters and represents one of the most remarkable evolutionary solutions to the challenges of living in an alien environment. For within the body of this eight-armed invertebrate beats not one, not two, but 3 distinct hearts working in coordinated harmony to sustain its extraordinary life. 2 of these hearts, known as branchial hearts, are positioned strategically within the creature's body cavity near the gills, where they serve the crucial function of pumping oxygen-rich blood through the delicate gill tissues, extracting dissolved oxygen from the surrounding seawater in a process that mirrors the respiratory mechanisms of fish and other aquatic organisms. The third heart, called the systemic heart, sits centrally within the creature's body and assumes the primary responsibility of circulating this oxygenated blood throughout the entire octopus, delivering vital nutrients and oxygen to every muscle, nerve, and organ that comprises this intelligent being. The mechanism behind this tripartite cardiovascular system emerges from the octopus's particular biological needs and the constraints imposed by its invertebrate physiology. For unlike mammals with their single four-chambered heart, the octopus requires additional pumping stations to maintain adequate blood pressure and circulation through its distributed limbs and diffuse nervous system. What makes this fact even more extraordinary, and perhaps what renders it difficult for the human mind to fully internalize, is that this three-heart system remains so fundamentally alien to our own experience that we struggle to imagine it as normal, despite the fact that it has proven to be an entirely successful and viable solution for millions of years of octopus evolution, demonstrating that nature operates according to principles far more flexible and creative than the singular patterns we observe in our own ma. Deep within the microscopic world, there exists a creature so remarkably resilient that it defies the very conditions we consider absolutely lethal to all known life forms, a being no larger than a grain of sand that has been launched into the vacuum of outer space and returned to Earth completely unharmed, ready to resume its normal biological functions as if nothing extraordinary had occurred at all. These organisms, known scientifically as tardigrades and colloquially as water bears or moss piglets, are eight-legged microscopic animals that inhabit moist environments across the planet, from rainforests to mountaintops, yet possess an almost supernatural ability to enter a state called cryptobiosis whenever their environment becomes hostile or inhospitable. When conditions become unbearably dry or when they face extreme temperatures or radiation, tardigrades essentially shut down their metabolic processes to nearly imperceptible levels, expelling water from their bodies and entering a dormant state where they require virtually no oxygen, no nutrients, and can withstand pressures and temperatures that would instantly obliterate any other organism known to science. Scientists have deliberately placed tardigrades into vacuum chambers that replicate the exact conditions of open space, and these creatures survived not only the complete absence of atmospheric pressure, but also the intense radiation and cosmic rays that bombard anything unshielded in the cosmos, demonstrating a level of biological toughness that seems to contradict every principle we understand about what life requires to persist. The mechanism behind this extraordinary survival capacity appears rooted in their ability to synthesize specialized proteins and sugars that protect their cellular structures from damage, allowing their DNA to remain intact even when exposed to radiation doses thousands of times higher than what would kill a human being instantaneously. Deep within the eucalyptus forests and grasslands of Australia, a remarkable biological phenomenon occurs that seems to defy the basic laws of physics and anatomy that govern most mammals on Earth. The wombat, a stocky and muscular marsupial that weighs between 20 and 35 pounds, produces fecal matter in the shape of perfect or near-perfect cubes, a characteristic so unusual that it remained largely undocumented in scientific literature until relatively recent times. These cubic droppings are not accidents of nature, but rather the result of a highly specialized intestinal structure and muscular system that has evolved over millions of years to serve a very specific purpose within the wombat's ecosystem. The walls of the wombat's intestinal tract contain muscles that are asymmetrically distributed, meaning they are stronger in certain areas than in others, and this uneven muscular development works in conjunction with the animal's naturally low-moisture diet to gradually shape the feces into distinct geometric forms as they move through the digestive system. Scientists who have studied this phenomenon in detail have discovered that the cubic shape serves as an effective territorial marker, as the flat sides of these cube-shaped droppings prevent them from rolling away in the wind or tumbling down hillsides, keeping them prominently displayed on rocks and logs where other wombats will notice them. The shape also appears to maximize surface area exposure, which allows the scent-marking chemicals within the waste to be more effectively broadcast to other members of the species, making the wombat's presence known across a wider territory. What makes this adaptation truly fascinating is that it represents an entirely different evolutionary path from every other mammal on the planet, which all produce either spherical, cylindrical, or irregularly shaped fecal matter, suggesting that wombats faced unique environmental pressures that Imagine standing at the base of a massive mountain, and then imagine ascending to its peak, climbing thousands of meters higher into the sky. If you were to wear an extraordinarily precise atomic clock during this journey, a clock so accurate that it measures billionths of a second, you would discover something profoundly counterintuitive. The clock at the mountaintop would tick faster than an identical clock left behind at sea level. This is not a theoretical abstraction or a mathematical curiosity confined to physics textbooks. This is observable, measurable reality. Time literally moves at different rates depending on where you are positioned within a gravitational field. The stronger the gravity pulling on you, the slower time passes. Conversely, the weaker the gravitational pull, the faster time advances for your body and everything around you. This phenomenon, known as gravitational time dilation, emerges directly from Einstein's theory of general relativity, which describes gravity not as a force, but as the curvature of spacetime itself. And this curvature has the profound effect of altering the rate at which time flows. The mechanism underlying this strange reality is fundamentally elegant. Massive objects bend the fabric of spacetime around them, much like how a heavy ball placed on a rubber sheet creates a depression that curves the surface. The closer you are to that massive object, the deeper you rest within that curvature, and the slower time ticks for you relative to someone farther away. Astronauts orbiting Earth in the International Space Station age microscopically slower than people on the planet's surface, a difference so minuscule that our bodies cannot perceive it, yet it is absolutely real and has been confirmed countless times through precise atomic clock measurements. Yet despite decades of verification and acceptance within the scientific community, this remains profoundly difficult for our intuitions to grasp. When we think about ancient history, our minds tend to create a linear timeline where everything fits neatly into distinct eras, separated by vast gulfs of time that feel appropriately distant from one another. Yet the reality of temporal overlap between historical events often strikes us with profound disbelief when we actually consider it with careful attention. The construction of the Great Pyramid of Giza, that monumental wonder completed around 4,600 years ago during Egypt's 4th dynasty under Pharaoh Khufu, coincided with a period when woolly mammoths still roamed the frozen regions of the Arctic, particularly on remote islands in the far north where small populations persisted in isolated refuges. This means that somewhere on Earth, while Egyptian workers were arranging limestone blocks on the Giza Plateau and engineers were calculating angles and weights, living mammoths were walking across Siberian terrain and the islands north of the Siberian coast, breathing the same air under the same moon that hung over the pyramids being built. The psychological mechanism that makes this difficult to accept stems from our tendency to compartmentalize history into separate chapters that feel almost entirely disconnected from one another, as though ancient Egypt existed in a completely different reality from Arctic prehistory. We imagine mammoths as creatures of an impossibly distant ice age, creatures belonging to an entirely separate world from human civilization, yet the mathematical reality of dates and calendars reveals an astonishing overlap that our intuition struggles to accommodate. This disconnect persists in our collective consciousness because we have organized knowledge into categories that emphasize difference rather than simultaneity, creating mental silos where mammoths belong to prehistory and pyramids belong to the beginning of recorded history, even though they shared the same moment in actual time. Consider for a moment the vastness of the night sky above you, that seemingly infinite expanse dotted with countless pinpricks of light that have captivated human imagination for millennia. And then consider the forests and woodlands and scattered trees that cover our planet's surface in green abundance. And the remarkable truth is that there are actually more trees on Earth than there are stars visible in our entire galaxy. Recent scientific estimates suggest there are approximately 3 trillion trees currently growing on our planet, while the Milky Way contains somewhere between 100 billion and 400 billion stars, a number that initially seems incomprehensibly large until we account for the sheer density of trees across every continent and ecosystem. This fact persists in our collective consciousness as deeply counterintuitive because we have spent our entire evolutionary history looking upward at the night sky and feeling the profound weight of cosmic immensity, as if the stars represent the ultimate measure of abundance and infinity, yet we walk beneath and among trees without extending that same sense of awe to the terrestrial world surrounding us. The psychological mechanism at work here involves the natural human tendency to associate visual vastness with actual quantity, since stars appear to fill the entire dome of the sky above us in all directions, creating an impression of countless multitudes, while trees, though abundant, occupy discrete locations on the ground where we tend to perceive them as individual objects rather than as components of an incomprehensibly large collective. We have normalized this perceptual bias because our ancestors' survival depended more on understanding the celestial sphere for navigation and timekeeping than on counting individual trees, and that ancestral prioritization continues to shape our modern intuitions about quantity and scale, making it persistently difficult for us to Every human being on this planet emits a continuous, faint luminescence that can be detected and measured with specialized thermal imaging equipment, a phenomenon that science has thoroughly documented yet remains almost entirely unknown to the general population. The human body radiates infrared light as a natural consequence of maintaining its core temperature at approximately 37 degrees Celsius. And while this glow exists entirely outside the visible spectrum that our eyes can perceive, it is nonetheless real and measurable in every sense. When thermal cameras designed to detect infrared radiation are pointed at a living human body in a completely dark room, they reveal a distinctive glowing silhouette that maps precisely to the contours of the person's form, with brighter areas indicating regions of higher metabolic activity and greater heat generation. This is not metaphorical or abstract in any way. It is a direct physical consequence of thermodynamics and the laws of energy conservation that govern all living systems. The human body must continuously convert chemical energy from food into heat energy to maintain life, and this heat energy naturally radiates outward into the environment as electromagnetic radiation in the infrared range. Our skin and tissues absorb and re-emit this thermal radiation constantly, creating an invisible aura of warmth that surrounds every living person at every moment of their existence. Despite this being a fundamental and scientifically verifiable aspect of human biology that has been understood and documented for decades through thermal imaging technology, most people go through their entire lives completely unaware that they are literally glowing in the darkness around them. The knowledge exists in scientific literature and thermal imaging fields, yet it has somehow failed to penetrate popular consciousness or cultural awareness in any meaningful way. Every single day, your body is engaged in a process of systematic renewal that most people never truly consider or comprehend. A continuous cellular replacement that means the person you are today is physically different from the person you were merely weeks ago. Scientists estimate that approximately 330 billion cells die and are replaced in your body each and every day, a staggering number that represents a complete cellular turnover occurring roughly every 7 to 10 years, depending on the specific tissue and organ system involved. Your skin cells are replaced entirely every 2 to 4 weeks, your red blood cells are regenerated every 120 days, and your bone cells are entirely refreshed every 10 years through a process called bone remodeling, which means that the skeleton supporting your body right now is fundamentally different from the skeleton that held you upright a decade ago. The liver, one of your body's most resilient and regenerative organs, can replace itself in just 5 months, while your stomach lining renews itself every 3 to 5 days because of the harsh acidic environment it must endure. Even your DNA is being continually repaired and replicated as cells divide and multiply, with specialized mechanisms detecting and correcting errors that occur during this process millions of times per day. Yet despite this constant and documented reality of physical transformation occurring within us at every moment, most people continue to identify with and conceptualize themselves as static, unchanging entities possessing a sense of continuous permanent identity that contradicts this biological truth. We speak of ourselves as if we are the same person we were in childhood, maintaining narratives and self-concepts that persist across decades even though the physical matter composing our bodies has been almost entirely replaced multiple times over. When you wake up in the morning and measure yourself against a door frame or stand beside someone you see every day, you are genuinely taller than you will be by evening, and this remarkable transformation happens to virtually every human being without exception or variation. The difference typically ranges from half an inch to a full inch in height, which represents a measurable and significant change in your physical stature that occurs purely through the natural processes of your body during sleep and wakefulness. This phenomenon occurs because your spine contains numerous intervertebral discs that are composed largely of water and cartilaginous material, and throughout the day these discs become compressed and dehydrated as you move around, sit in chairs, stand upright against gravity, and engage in all the various physical activities that make up daily human existence. During the night when you lie down horizontally in bed, your spine is relieved of the constant downward pressure of gravity that has been crushing those discs throughout your waking hours. And this relief allows the discs to reabsorb fluids and expand back to their fuller original dimensions, which effectively adds measurable length to your vertebral column and therefore to your overall height. The compression that occurs during the day is gradual and continuous, happening so slowly and subtly that you never consciously notice your body becoming incrementally shorter as the hours pass. Yet by evening, you may be nearly an inch shorter than when you woke up that morning. This process reverses completely during sleep, and when you lie down for 7 to 9 hours, your discs plump back up like sponges absorbing water, restoring your spine to its maximum length and making you taller once again when you finally step out of bed. Consider the remarkable chemical environment that exists within your stomach at this very moment, a place of such intense acidity that it can break down not only the proteins in your food, but also materials we might assume to be virtually indestructible. And among these materials are razor blades themselves, which when introduced into the human stomach are systematically dissolved by the hydrochloric acid present there. A fact that seems almost impossible given our everyday experience with razor blades as objects of frightening sharpness and apparent permanence. The stomach produces hydrochloric acid with a pH of approximately 1 to 2, making it one of the most corrosive substances that exists naturally within the living body. And this acid serves the vital purpose of breaking down food into a digestible paste, while simultaneously killing most bacteria and pathogens that might otherwise cause harm. Yet the same chemical force that digests your lunch also has the capacity to dissolve the metallic structure of a razor blade, slowly and methodically turning the sharp edges into nothing more than dissolved iron compounds that pass harmlessly through your digestive system. The psychological mechanism behind our disbelief in this fact stems from a fundamental category error in how we think about different contexts and environments. For we associate razor blades with permanence and danger in the dry world of air and ordinary conditions, yet we fail to recognize that those same conditions are entirely different from the intensely chemical environment of the stomach. And this disconnect between our intuitive understanding and the actual science creates a cognitive gap that makes the claim feel not merely surprising, but actually unbelievable. Even though medical literature and toxicology research have documented this phenomenon extensively through both animal studies and rare cases of human ingestion. Within your body at this very moment exists a reality that defies the intuitive sense of self that you carry through the world. For the number of bacterial cells that reside within your physical form actually outnumbers the human cells that compose your body, a fact that has been scientifically verified and refined through decades of microbiological research and cellular counting methodologies. When you consider your own existence as a singular organism, you are in truth acknowledging a cooperative ecosystem in which approximately 38 trillion bacterial cells coexist alongside roughly 37 trillion human cells, meaning that by the strict mathematics of cellular quantity, you are technically more bacteria than you are human according to this particular measure of composition. These bacterial inhabitants occupy nearly every conceivable space within your body, dwelling in your digestive tract where they assist in breaking down food and synthesizing essential vitamins, residing on your skin where they form protective barriers against harmful pathogens, and establishing communities throughout your respiratory system, oral cavity, and urogenital tract in ways that are fundamentally essential to your survival and well-being. The mechanism by which we have come to accept this cohabitation without psychological distress relates largely to the invisibility of these organisms and the evolutionary advantage they provide, since bacteria have inhabited human bodies for countless generations and have become so thoroughly integrated into our biological processes that we have developed interdependent relationships that neither party can easily abandon. What persists as remarkable is how successfully we maintain a sense of singular bodily autonomy and individual identity despite this fundamental truth of our microbial composition, continuing to refer to ourselves in singular terms and to feel ownership over bodies that are in reality collaborative. Have you ever noticed that old windows in historic buildings, particularly those constructed several centuries ago, appear thicker at the bottom than they do at the top, with the glass seeming to pool downward as if it had slowly dripped over the generations like honey moving through an hourglass. This observation has captivated many people who encounter these ancient panes, leading them to believe that glass, despite appearing solid and rigid, is actually a slow-moving liquid that continues to flow imperceptibly across vast stretches of time. The mechanism behind this compelling misconception lies in our natural tendency to seek patterns and explanations for what we observe, combined with our limited understanding of how materials behave across different timescales and conditions. When we see glass thicker at the bottom of old windows, our minds immediately construct a narrative that explains this visual evidence through the lens of flowing liquid, a concept we understand from everyday experience with water and other transparent fluids. The truth, however, is far more nuanced and reveals something fascinating about how glass actually forms and settles. The real reason historical windows appear thicker at the bottom relates entirely to the manufacturing processes of earlier centuries, when artisans created glass by hand through techniques that naturally produced uneven thickness, with the bottom portions intentionally made heavier to provide stability and prevent warping during the long curing process. Window installers of old also deliberately positioned thicker glass toward the base to provide additional structural support and durability where stress concentrations naturally occurred. Glass, in its true molecular state, is actually a supercooled liquid at the atomic level, though this technical distinction becomes irrelevant when discussing practical timescales, as the viscosity is so extraordinarily high that no perceptible movement W. Imagine yourself floating in the vast emptiness of outer space, suspended in the vacuum where not a single molecule of air surrounds your body, and despite an enormous explosion occurring just meters away from where you float, you would hear absolutely nothing at all, not a whisper or a rumble or any acoustic sensation whatsoever because sound, unlike light, cannot travel through the absence of matter. This fundamental principle of physics reveals something we rarely contemplate despite encountering it throughout our entire existence. Sound is not an independent phenomenon that simply travels freely through nothingness, but rather it is entirely dependent upon the presence of a physical medium through which to propagate, whether that medium is air, water, metal, or any other substance composed of atoms and molecules. When a speaker cone vibrates or a vocal cord oscillates, it creates pressure waves by pushing against the molecules immediately surrounding it, and these molecules then collide with their neighbors in a cascading effect that continues outward in all directions, transferring the vibrational energy from one particle to the next in an endless chain reaction that we perceive as sound reaching our ears. The denser the medium, the faster sound travels through it, which is why sound moves more than 4 times faster through water than through air, and even faster through solid materials like steel or concrete, where the tightly packed atoms efficiently transfer vibrations with minimal resistance. What makes this scientific reality so psychologically fascinating is that we have spent our entire lives immersed in an atmosphere, surrounded by air molecules at sea level that we never see or think about, which creates an illusion that sound is somehow independent and self-sufficient, able to exist and travel by itself without requiring anything at all. When astronauts venture into space and spend extended periods aboard orbital stations or spacecraft, their bodies undergo a remarkable transformation that seems almost impossible until you understand the mechanics at work. These trained professionals, who have spent years preparing for their missions with rigorous physical conditioning, frequently return to Earth noticeably taller than when they departed, with some astronauts reporting height increases of up to 3 inches during missions lasting several months. This transformation occurs because in the microgravity environment of space, the human spine experiences a fundamental change in the forces acting upon it. On Earth, gravity constantly compresses the vertebral column, pushing down on the discs and bones that make up the spinal structure, creating a consistent downward pressure that reduces our overall height throughout the day and even more so as we age. However, once an astronaut enters the weightless environment of space, this relentless gravitational compression ceases entirely, and the spinal discs, which are made of cartilage and fluid, expand and decompress without resistance. The vertebrae can spread apart more freely, the intervertebral discs absorb more fluid and swell, and the entire spine elongates in a way that simply cannot happen on Earth. This is not a permanent change for most astronauts, as the human body quickly readapts to gravitational forces upon return, and within days or weeks the spine compresses again and height returns to normal. Yet the phenomenon reveals something profound about how our bodies are shaped by the constant, invisible force of gravity, a force so omnipresent in our lives that we rarely consider how fundamentally it molds our physical form at every moment of every day. When you stand on the ground and look toward the horizon, the landscape appears to stretch outward in all directions with a subtle curvature that our eyes struggle to perceive from ground level. Yet our planet is not the perfect sphere that many of us visualized during childhood, but rather an oblate spheroid, meaning it bulges slightly at the equator and is flattened at the poles, a difference of approximately 21 kilometers between the equatorial radius and the polar radius. This shape exists because the Earth spins on its axis, and as it rotates, the centrifugal forces push the mass outward most strongly at the equator, where the rotational velocity is greatest, while the poles experience minimal outward force and therefore maintain a more compressed, flattened appearance. The reason our minds struggle to accept or remember this seemingly minor distinction stems from how we are taught planetary science in schools, where globes and textbooks typically depict Earth as a perfect sphere for simplicity and visual clarity, making the spheroidal shape appear to be an obscure technical detail rather than a fundamental physical characteristic. Additionally, the difference between the equatorial and polar radii represents only about 1/3 of Earth's mean radius, a proportion so small that it would be nearly imperceptible on any globe sized for a classroom. Yet this minuscule deviation has profound consequences for planetary physics, satellite orbits, and geodetic calculations. We normalize and overlook this reality because our daily experience of Earth's shape is shaped almost entirely by our local perspective, where the curvature becomes apparent only at altitudes above 50 kilometers, and our evolutionary history predisposed us to perceive the world as flat and manageable at the scale of human movement. When we observe mountains in their seemingly static grandeur, we tend to perceive them as ancient, unchanging monuments to geological time, permanent fixtures of our landscape that have existed in their present form for countless millennia. Yet the scientific reality is that mountains across the world are actively growing even at this very moment, rising upward through the continuous processes of tectonic plate collision and uplift, with some peaks gaining several millimeters or even centimeters of elevation each year. The Himalayas, for instance, continue their inexorable climb skyward at a rate of approximately 1 to 2 centimeters annually, driven by the relentless collision of the Indian plate pushing northward into the Eurasian plate, a process that has been occurring for millions of years and shows no signs of abating. This growth happens through multiple mechanisms working in concert: direct tectonic uplift from plate collision, isostatic rebound, where the weight of accumulated rock pushes lighter crustal material upward, and the addition of new material through volcanic activity and mineral accumulation. Our minds struggle to accept this reality because mountains occupy a temporal scale so vastly different from human experience that their motion becomes imperceptible to us. We live our entire lives without noticing any visible change in a mountain's height, and this imperceptibility creates a psychological illusion of permanence. We have normalized the idea of mountains as eternal and immobile because geological processes operate at speeds that fall entirely outside our conscious perception. Yet we nonetheless possess the scientific instruments and measurements to confirm that these colossal formations are slowly, but definitively transforming, growing, and reshaping the very face of our planet in ways that will only become dramatically obvious to our descendants thousands or millions of years hence. Beneath your feet, at this very moment, the ground you stand upon is moving imperceptibly across the surface of our planet, traveling at a rate of approximately 2 to 10 centimeters each year, depending on which continent you inhabit. This continental drift, a phenomenon that once seemed impossible to most scientists and laypeople alike, represents one of the most profound geological realities of our world, yet it remains so gradual and persistent that we have become entirely desensitized to its constant occurrence. The African continent, for instance, drifts eastward at roughly 5 centimeters annually, while the Pacific plate moves in a different direction altogether, and these movements accumulate over millions of years to reshape the very geography of our planet in ways that fundamentally alter coastlines, create mountain ranges, and trigger the earthquakes and volcanic eruptions that punctuate human history. The mechanism driving this motion operates at depths we can scarcely comprehend, where molten mantle material beneath the Earth's crust generates heat and pressure sufficient to move masses of rock the size of entire continents. A process so slow that human perception cannot detect it directly, yet so persistent that geological evidence reveals dramatic transformations across time scales measured in tens of millions of years. What makes this concept particularly difficult for our minds to fully embrace is that the movement occurs at a speed so gradual that it falls below the threshold of human sensory awareness, allowing us to live our entire lives upon moving ground without ever feeling a single moment of displacement, creating a profound disconnect between the mathematical reality of planetary motion and our immediate experiential understanding of a static, unchanging world around us. And this disconnect has become so normalized in our collective consciousness that we rarely pause to consider the staggering implique. The moon, that celestial body which has hung above our planet since its formation approximately 4.5 billion years ago, is not stationary in its relationship to Earth, but rather engaged in a slow and continuous recession that occurs year after year, measurable and relentless in its trajectory away from us. Through the careful measurements made possible by lunar laser ranging experiments, scientists have determined that the moon moves away from Earth at a rate of approximately 3.8 centimeters every single year, a distance so minuscule in human terms that we might dismiss it entirely, yet cumulatively significant over the vast stretches of geological time that define our planetary history. This recession occurs because of the gravitational interaction between Earth and Moon, specifically through the mechanism of tidal forces, where the Moon's gravity pulls on Earth's oceans and landmasses, creating bulges of water and rock that actually pull the Moon forward in its orbit, gradually transferring angular momentum, and causing the satellite to spiral outward into a higher and more distant orbit with each passing century. The mechanism is counterintuitive to many because we imagine gravity as a force that pulls objects together, yet in this case, the tidal dissipation of energy actually results in separation, a paradox that challenges our intuitive understanding of how celestial mechanics function at scales both vast and incomprehensibly slow. Despite the fundamental strangeness of this concept, the reality of lunar recession has become accepted scientific fact, woven seamlessly into our understanding of the Moon's history and future, yet we rarely contemplate what this means for the long-term fate of our night sky, how our Moon will continue its gradual escape across millions of years, eventually becoming smaller and more distant in appearance until it may no longer entirely eclipse the Sun during solar eclipses. Consider the peculiar state of water when it exists in a condition so finely balanced that three distinct phases, solid ice, liquid water, and water vapor, coexist simultaneously in perfect equilibrium, a phenomenon known as the triple point, which occurs at precisely 0.01 degrees Celsius and a pressure of 611.65 pascals. A razor-thin threshold where the molecular forces governing each state achieve such delicate harmony that all three forms maintain their existence together without converting into one another. This triple point is not merely a theoretical construct, but rather a measurable, observable reality that physicists and chemists have confirmed countless times in laboratory settings, where water molecules arrange themselves in such a way that some remain locked in crystalline solid formation, while others break free into liquid motion, while still others escape entirely into gaseous invisibility, all occupying the same space and time with no preference for transformation. The reason this triple point exists relates to the fundamental nature of phase transitions, which occur when temperature and pressure create conditions where the energy states of molecules reach perfect indifference, where the forces pulling molecules together into solid structure balance precisely against the forces pushing them apart into vapor, creating this momentary equilibrium that seems almost impossible given how dramatically water normally transforms between its states. Yet despite possessing complete scientific understanding of why the triple point exists and having successfully demonstrated it in controlled environments, there remains something deeply unsettling about accepting that water can simultaneously be solid, liquid, and gas, that these three seemingly incompatible states can coexist without conflict, perhaps because our everyday experience never allows us to witness this phenomenon as the conditions. Imagine standing at the top of a tall building on a windless day, holding two objects in your hands, a feather and a bowling ball. Our immediate intuition tells us that if we release them simultaneously, the bowling ball will plummet to the ground far more quickly than the feather, which will drift and flutter its way downward in a leisurely fashion. This intuition feels so deeply embedded in our everyday experience that we rarely question it, yet this perception represents one of the most fundamental misunderstandings about how our physical world actually operates. The scientific reality, proven countless times through controlled experiments and observation, is that in the absence of air resistance, both objects would fall at precisely the same rate of acceleration, hitting the ground at nearly the same moment. The bowling ball and the feather would accelerate downward at approximately 9.8 meters per second squared, a constant that applies to all objects regardless of their mass or density. The psychological mechanism underlying this persistent misconception stems from our evolutionary adaptation to a world where air resistance is always present and profoundly impacts how we perceive falling objects. Our ancestors never experienced a perfect vacuum, and throughout human history, we have observed that heavier, more aerodynamic objects do indeed fall faster than lighter, more air-resistant ones, reinforcing this false belief through repeated sensory confirmation. This observation became so deeply encoded in our conceptual framework that we treat it as an immutable law of nature rather than recognizing it as merely an artifact of living within an atmosphere. What makes this misconception particularly fascinating is that even after learning the scientific truth, our brains continue to resist it, clinging to the intuitive model that matches our lived experience more readily than accepting the counterintuitive reality that Consider the remarkable fact that in the entire history of human civilization, across billions upon billions of individual people who have ever lived on this planet, no two fingerprints have ever been found to be identical, and statistically speaking, no two fingerprints will ever be identical for as long as humanity exists. Every ridge, every whorl, every loop and arch that forms on the tips of your fingers during fetal development between weeks 10 and 19 of gestation is entirely unique to you and you alone, creating a pattern so specific that it has become the gold standard for personal identification across the globe. The probability of two randomly selected fingerprints matching is estimated at approximately 1 in 64 billion, a number so astronomical that it transcends our normal capacity for understanding likelihood. This uniqueness emerges from the chaotic process of fetal development itself, where the formation of skin ridges depends on countless microscopic variables, including amniotic fluid pressure, maternal hormone levels, the precise timing of cellular division, and random fluctuations in growth rates that cannot be predicted or replicated in another individual. What makes this phenomenon particularly fascinating is that we have accepted this reality so completely that we have built entire systems of law enforcement, criminal justice, and border security around this single biological principle. Trusting our most important systems of identification to pattern we cannot voluntarily control and cannot duplicate even if we tried. We take fingerprints at birth, at border crossings, during criminal arrests, when obtaining certain licenses, and this practice persists globally across vastly different cultures and legal systems with virtually no questioning of its fundamental reliability. Consider the simple act of humming, that effortless vocalization where you produce a continuous, melodic sound with your mouth closed, allowing the vibrations to resonate through your vocal cords and emerge as a gentle hum that fills the space around you with familiar music or melody. Now imagine attempting this exact same activity while simultaneously pinching your nostrils closed between your thumb and forefinger, blocking any air from passing through your nasal passages, and you will discover something remarkable and utterly frustrating happens immediately. Something that defies what your brain expected would occur based on countless previous experiences with humming throughout your lifetime. The reason this peculiar phenomenon occurs relates fundamentally to how human sound production actually functions, which is quite different from how most people intuitively believe it works in their everyday understanding of their own bodies. When you hum with your nose open, the sound waves you produce require a continuous pathway for resonance and vibration, and crucially, the air pressure behind those vibrations must have somewhere to naturally equalize and escape, which happens primarily through your nasal cavity rather than your mouth, since your mouth remains closed during humming. The moment you pinch your nose shut, you create an impossible situation where the air pressure builds up with no escape route available, causing the vibrations in your vocal cords to collapse entirely and rendering the humming sound completely inaudible or absent altogether, as if your ability to produce this sound has simply vanished from your body. What makes this fact particularly interesting is how few people consciously understand this mechanism, despite having hummed thousands of times throughout their lives, suggesting that we operate most of our bodies on a level far below conscious awareness or deliberate understanding, performing complex actions. Just as your fingerprints form an intricate and completely individual pattern that law enforcement agencies have relied upon for over a century as a definitive marker of personal identity, your tongue possesses an equally distinctive surface topography that is entirely unique to you and you alone, a fact that remains largely unknown to the general population despite its profound implications for forensic science and personal identification. The surface of your tongue is covered in thousands of tiny structures called papillae, which are small bumps and ridges that create a complex three-dimensional landscape completely unlike anyone else's tongue. And these papillae vary in size, shape, distribution, and spatial arrangement in ways so intricate and individualized that forensic experts have begun cataloging tongue prints much like they catalog fingerprints, recognizing that no two people in the world, not even identical twins who share nearly identical genetic material, possess the same tongue print pattern. The psychological reason we remain unaware of this remarkable fact is rooted in the simple truth that we rarely examine our own tongues closely or think of them as potential identification markers, as our tongues are primarily associated with basic functions like taste, speech, and eating, rather than with identity verification or biometric security systems. And so the tongue remains one of the most overlooked and underappreciated repositories of personal uniqueness that your body possesses. What makes this fact particularly fascinating is that tongue prints could theoretically be used in criminal investigations, security systems, and medical records with the same reliability as fingerprints. Yet society has not widely adopted this biometric identifier despite decades of scientific research confirming its validity and uniqueness, suggesting that our collective normalization of fingerprinting as the standard has created a kind of cognitive. When we observe newborn infants in their first moments of life, we are witnessing one of the most remarkable truths about human development, yet it remains largely unknown to the general population. The human eye, that remarkable organ of sight and emotional expression, reaches its full adult size by the time a child is born, and throughout the remainder of our entire lives, our eyes will never grow any larger than they are in that inaugural moment of existence. This counterintuitive fact challenges our intuitive understanding of how growth and development work, since we naturally assume that all parts of our body expand proportionally as we mature from infancy into adulthood. Our bodies undergo dramatic transformations during childhood and adolescence, with our bones lengthening, our muscles expanding, and our heads becoming increasingly proportional to our torsos, yet our eyes remain static in their dimensions throughout these profound physical changes. The reason this occurs lies in the fundamental architecture of human development and the specific biological timeline that governs different organ systems. The eye develops extremely rapidly during fetal development, completing its growth trajectory well before birth, because vision is a critical survival skill that infants need from their very first moments of life. Unlike other organs that benefit from continued growth and expansion during childhood, the eye's optical properties are determined by precise measurements, and any significant changes to the cornea or lens after birth would actually impair vision rather than improve it. This biological reality means that while a newborn's eyes may appear disproportionately large relative to their delicate facial features, this proportion gradually shifts as the rest of the face and skull expand around these stationary ocular structures. Consider for a moment the remarkable organ residing within your skull, that wrinkled mass of neural tissue that somehow generates your thoughts, memories, and consciousness itself, and consider how much energy it actually requires to keep it functioning throughout your day. Your brain, despite comprising only about 2% of your body's total weight, consumes approximately 20% of all the energy that your body produces, which means that this single organ demands 10 times more energy relative to its size than the average tissue in your body. This extraordinary metabolic demand becomes even more striking when you think about what your brain is actually doing during most of your waking hours, which is not necessarily solving complex mathematical problems or creating profound works of art, but rather maintaining baseline operations, processing sensory information, and managing the countless automatic functions that keep you alive without any conscious effort whatsoever. The brain requires this tremendous amount of energy because it maintains billions of neurons, each one constantly firing and communicating with thousands of other neurons through chemical and electrical signals. And this neural activity generates an enormous amount of metabolic demand that requires a steady, uninterrupted supply of glucose and oxygen delivered through your bloodstream. Most people do not realize just how metabolically expensive thinking actually is, and they certainly do not appreciate that their brain is burning fuel at this extraordinary rate even when they are resting, sleeping, or simply sitting quietly without engaging in any obvious mental activity. What makes this fact particularly fascinating is that your brain's energy consumption remains relatively constant whether you are concentrating intensely or daydreaming lazily, because the brain maintains this high metabolic baseline regardless of how actively you are using it, which, for decades, neuroscience operated under a fundamental assumption that shaped our entire understanding of the human brain, and that assumption was that once you were born, the neurons you possessed were essentially all the neurons you would ever have, a concept so deeply embedded in medical education and popular understanding that it became accepted as absolute truth. The belief suggested that unlike other cells in your body, which constantly renew themselves through division and replacement, your brain cells existed in a static state of permanent diminishment from the moment of your birth onward, with each neuron lost to injury, disease, or simple aging representing an irreplaceable piece of cognitive capacity that would be gone forever. This idea created a psychological framework where people understood their brains as finite machines operating on borrowed time, where every concussion or stroke carried not just immediate consequences, but the weight of permanent cellular loss that could never be recovered. Yet beginning in the 1990s, researchers discovered something that fundamentally contradicted this widely accepted principle. The brain possesses the remarkable capacity to generate entirely new neurons through a process called neurogenesis, a discovery so significant that it eventually earned researchers a Nobel Prize in physiology and medicine. The new neurons form primarily in the hippocampus, the region critical for memory formation and emotional regulation, and this generation continues throughout your entire lifespan, with your brain creating thousands of new neurons every single day, even as you sleep or go about mundane daily activities. The mechanism behind this regenerative capacity involves neural stem cells, specialized cells that retain the ability to divide and differentiate into mature neurons, responding to various stimuli including physical exercise, cognitive challenges, learning new information. Within the depths of your abdomen lies a complex neural network so intricate and so independent that scientists have given it its own name. The enteric nervous system, often referred to as your second brain, and it contains approximately 100 billion neurons distributed throughout your gastrointestinal tract, which is nearly equal to the number of neurons found in your spinal cord. This network operates with remarkable autonomy, managing the entire process of digestion from the moment food enters your mouth until waste leaves your body. And it does this almost entirely without conscious input or direction from your central nervous system. The gut's nervous system controls the muscular contractions that move food through your digestive tract, regulates the secretion of digestive enzymes and acids, manages nutrient absorption across the intestinal walls, and even influences your mood and emotional state through the production and regulation of neurotransmitters like serotonin and dopamine, which are produced in far greater quantities in your gut than in your brain. This explains the genuine biological basis for phrases like having a gut feeling or experiencing butterflies in your stomach, because your enteric nervous system communicates bidirectionally with your central nervous system through the vagus nerve, creating a constant dialogue between your mind and your digestive organs. The implications of this discovery have revolutionized our understanding of human physiology and psychology, yet most people move through their daily lives completely unaware that they are harboring an entire secondary nervous system that is simultaneously processing information, making decisions, and influencing their thoughts and feelings in ways that neuroscience is only beginning to fully comprehend and map out. Your heart is an organ that operates with remarkable autonomy, continuing to function even when completely severed from your body, a phenomenon that challenges our fundamental understanding of life itself and the dependencies we assume biological systems must maintain to survive. When a heart is removed from the human body during organ transplantation or in laboratory settings, it does not immediately cease beating. Rather, it continues to contract rhythmically for several minutes or even longer, provided it receives adequate oxygen and nutrient supply through artificial perfusion systems or specially formulated solutions that mimic the conditions of circulating blood. This occurs because the heart contains its own electrical conduction system, a network of specialized cardiac cells that generate and propagate electrical signals independently of the brain, meaning the organ does not require neural input from the central nervous system to initiate or maintain its beating rhythm. The sinoatrial node, located in the right atrium, functions as the heart's intrinsic pacemaker, spontaneously firing electrical impulses at regular intervals without any external command or conscious direction, a property known as automaticity that allows the organ to beat autonomously when isolated from the body. Scientists and surgeons have demonstrated this principle countless times in transplant medicine and experimental cardiology, observing donor hearts beating outside the body for extended periods, and some research has even involved keeping hearts functioning in specialized warm perfusion devices called organ care systems, which maintain the organ in a near physiological state while it waits for transplantation. The psychological difficulty we experience in accepting this fact stems from our deeply ingrained belief that the heart is the seat of consciousness and emotion, a poetic and cultural legacy that makes us perceive the heart as fundamentally in T. Consider for a moment the skeletal structure that holds your body upright as you lie in bed, the framework that has carried you through decades of walking, running, and moving through the world without complaint. Your bones, those pale architectural marvels hidden beneath your skin, possess a tensile strength that rivals or even exceeds that of steel, one of humanity's most prized industrial materials. When engineers test bone against steel in laboratory conditions, they discover that bone can withstand approximately the same amount of stress and strain as many common steel alloys, yet it accomplishes this feat while being significantly lighter and far more elegant in its construction. This seemingly impossible combination of strength and lightness emerges from bone's unique composite structure, which consists of a dense mineral matrix primarily composed of calcium phosphate and calcium carbonate, interwoven with organic collagen fibers that provide flexibility and resilience. The mineral components deliver the hardness, while the collagen delivers the flexibility, creating a material that neither pure mineral nor pure fiber could achieve alone, a biological engineering solution that human scientists have only recently begun to fully understand and replicate. Yet despite possessing this remarkable material already integrated into our bodies, we have spent centuries developing external armor and tools from inferior substances, searching outside ourselves for strength we already carried within. We marvel at steel bridges and steel buildings, celebrating human innovation, while the steel-equivalent structures supporting our own bodies remain invisible to our daily consciousness, taken for granted as simply the unremarkable scaffolding of existence. When you look inside your mouth and feel your teeth with your tongue, you might assume you're touching bone, since teeth are hard, white, and permanently anchored into your jaw. Yet the truth is that teeth are fundamentally different structures that only share some surface-level similarities with the skeletal system. Teeth are actually composed of multiple distinct layers, including enamel on the outside, which is the hardest substance in the entire human body and contains no living cells whatsoever, dentin beneath that layer which is softer than enamel and does contain microscopic tubes connected to nerve endings, and a central pulp chamber filled with blood vessels and nerves that keep the tooth alive. Bone, by contrast, is a living tissue that constantly remodels itself through a process where old bone is broken down and new bone is formed, allowing bones to heal from fractures and adapt to stress over time. Teeth cannot regenerate or repair themselves in this way. Once the enamel wears away, it's gone permanently, and if the dentin becomes exposed, it causes sensitivity rather than healing. The structural organization is also entirely different, as bones contain cells called osteocytes embedded within their mineral matrix, while teeth have no such cellular integration, making them biologically distinct organs rather than extensions of the skeletal system. Despite these fundamental differences, we persist in grouping teeth casually with bones in our everyday thinking and language, perhaps because they're both hard, calcium-based structures that appear similar at a glance. Yet this mental categorization obscures the remarkable biological reality that teeth occupy their own unique position in human anatomy. Functioning as specialized organs designed specifically for mechanical food processing, while maintaining properties that make them fundamentally incompatible with bone's regenerative capabilities. Every single strand of hair growing from your scalp is composed entirely of dead cells, a reality that becomes profoundly unsettling when you truly pause to consider what you are actually touching when you run your fingers through your hair or spend time styling and grooming these lifeless structures. The hair follicle itself, buried deep within your skin, is alive and actively producing new cells through a process of continuous division and growth. But the moment these cells are pushed upward and outward from the follicle, they undergo a dramatic transformation in which they lose their nucleus and cease all metabolic activity, becoming hardened and lifeless keratin proteins that are essentially biological waste products being extruded from your body. You spend considerable time and resources throughout your life maintaining, cleaning, conditioning, cutting, and styling these dead structures, applying expensive products to make them shine and feel soft. Yet you are fundamentally working with material that has no biological function or capacity to heal itself once damaged. The psychological disconnect here is profound because hair maintains the appearance of life and vitality, growing longer and responding to care in ways that feel organic and living. Yet this growth is merely the continuous extrusion of newly produced dead cells from a living follicle below the skin surface. We have built entire industries around the care and styling of dead cells, convincing ourselves that these lifeless structures deserve significant investment in terms of both time and money. And we judge ourselves and others largely based on the appearance and condition of hair despite knowing intellectually that we are literally grooming and maintaining biological waste. This strange normalization of spending hours each week attending to dead cells we cannot feel, and that cannot feel anything themselves, represents a curious disconnect between our rational understanding of. Your skin is constantly engaged in a remarkable process of renewal that most people never consciously acknowledge. Yet it occurs with such regularity and precision that you shed an entirely new outer layer approximately once every month throughout your entire life. The human body produces millions of new skin cells every single day, with the epidermis, which is the outermost layer of your skin, completely regenerating itself roughly every 28 to 30 days, meaning that the skin you had just 4 weeks ago is almost entirely gone and replaced with fresh cellular material. This phenomenon occurs because skin cells have a natural life cycle where they are born in the deeper layers, migrate upward toward the surface, become flattened and hardened as they approach the top, and eventually die and slough off as you move throughout your day, take showers, or even simply exist in the environment. The process is so efficient and automatic that your body sheds between 30,000 and 40,000 dead skin cells every single minute, accumulating to roughly 1.5 pounds of dead skin annually, which means that a significant portion of household dust is actually composed of your own shed skin cells mixed with those of other people in your home. What makes this process so fascinating from a biological perspective is that it represents your body's ingenious solution to protecting itself from the external world, as the skin must constantly defend against ultraviolet radiation, environmental toxins, mechanical damage, and microbial invasion. And the only way to maintain effectiveness in this protective barrier is through continuous replacement. The deeper layers of your skin remain largely stable, but this outermost layer must be disposable because it bears the brunt of environmental assault, and rather than trying to repair damaged cells, your body simply discards them and generates new ones to take their place. Your stomach is one of the most hostile environments within your body, a chamber of relentless chemical warfare where powerful acids and enzymes work continuously to break down everything you consume. And yet, remarkably, the delicate tissue that lines this organ manages to completely regenerate itself approximately every 7 to 10 days. Meaning that the stomach lining you had last week is almost entirely gone and has been replaced by fresh tissue in a process so thorough and efficient that it happens without you ever noticing or feeling anything amiss. The stomach produces hydrochloric acid strong enough to dissolve metal, and this acid would theoretically destroy the organ itself if not for an elegant protective system where specialized cells in the stomach wall secrete a thick mucus layer that shields the underlying tissue while simultaneously producing bicarbonate to neutralize acid near the surface. Yet this protective barrier itself cannot withstand the constant assault for long. Which is why your body has evolved this remarkable weekly replacement strategy where old cells are systematically shed and new ones are generated from stem cells in the gastric glands, a renewal process so fundamental to survival that it occurs in nearly every mammal with a stomach. The mechanism behind this regeneration involves a delicate balance of cellular signals and growth factors that trigger the death of old cells while simultaneously stimulating the proliferation of new ones. A biological choreography so precisely calibrated that if it malfunctions even slightly, conditions like gastric ulcers can develop where the protective lining erodes faster than it can be replaced. What is perhaps most striking about this phenomenon is how completely ordinary and unremarkable we have come to regard it, treating the stomach as merely another organ without appreciating the extraordinary feat of biological engineering that allows us to consume corrosive. It has long been observed that mosquitoes seem to prefer certain individuals over others in any given gathering, and this phenomenon has sparked considerable curiosity about what might drive such selective feeding behavior in these small but persistent insects. Scientific research has demonstrated that mosquitoes are indeed attracted to people with certain blood types more readily than to others, with type O blood emerging as the most attractive blood type to the majority of mosquito species, while type O blood tends to receive significantly less attention from these insects. The mechanism behind this preference operates at the chemical level, as mosquitoes possess highly developed sensory organs that allow them to detect subtle variations in the composition of human blood and the particular combinations of chemical compounds that differ from one blood type to another. When a person with type O blood comes into contact with mosquitoes, the insects are able to identify specific markers and compounds associated with that blood type, which trigger a stronger feeding response compared to other blood types, essentially making these individuals more appealing targets. This selective attraction has been observed consistently across multiple scientific studies, where researchers have exposed mosquitoes to different blood types under controlled conditions, and the results repeatedly demonstrated that mosquitoes exhibit a genuine preference pattern rather than a random selection process. What makes this phenomenon particularly interesting from a psychological standpoint is how readily people accept this information as fact without questioning why mosquitoes would have evolved such a preference, and how this belief has become deeply embedded in popular understanding despite the somewhat arbitrary nature of the preference itself. Consider the remarkable and deeply unsettling fact that human beings and bananas share approximately 50 to 60% of their DNA sequences, a biological reality that challenges our intuitive sense of separation from the natural world and reveals the profound interconnectedness of all living organisms on Earth. This genetic overlap emerges not because humans and bananas are particularly closely related in evolutionary terms, but rather because both species, despite their vast differences in complexity and consciousness, require the same fundamental molecular machinery to carry out the basic processes of life itself. The cells in your body and the cells of a banana both need to perform essential functions such as energy production, protein synthesis, cellular division, and metabolic regulation. And many of the genes that encode the instructions for these basic biological operations have remained remarkably similar across millions of years of evolutionary time. When scientists examine the genetic code of humans and compare it directly to that of bananas, they discover that a significant portion of genes are orthologous, meaning they share a common ancestry and perform essentially the same functions in both organisms, which explains why this genetic similarity exists at all. The psychological mechanism that makes this fact difficult for most people to accept relates to our deeply ingrained sense of human exceptionalism and our tendency to view ourselves as fundamentally distinct from other forms of life, particularly those that seem as simple and removed from our own experience as a fruit. We struggle with the notion that something as fundamentally human as our genetic code could overlap substantially with something as apparently foreign and inanimate as a banana. Yet this discomfort stems from a misunderstanding of what DNA actually represents and how evolutionary processes work across different species. While identical twins share nearly identical DNA sequences and develop from a single fertilized egg that splits during early pregnancy, their fingerprints remain distinctly and measurably different from one another throughout their entire lives. This phenomenon has been scientifically documented countless times, yet it continues to surprise people who learn about it, perhaps because we have become so accustomed to thinking of identical twins as being fundamentally the same in every biological way. The reason for this remarkable difference lies in the developmental process of fingerprints, which occurs during the second and third trimesters of pregnancy when small ridges begin to form on the skin of the fingertips and palms. These ridge patterns are not determined solely by genetic instructions, but are instead shaped by random environmental factors within the womb, including subtle variations in amniotic fluid pressure, the precise positioning of each fetus, minor differences in blood flow, and countless other microscopic conditions that differ between even the most closely positioned twins. Because identical twins develop in separate amniotic sacs, even when they share the same placenta, they experience slightly different mechanical pressures and environmental influences that guide how their skin ridges form and settle into their final patterns. Scientists understand that the genes provide a general blueprint for skin structure, but the actual detailed architecture of fingerprints emerges from this complex interplay between genetic potential and environmental randomness, making each twin's fingerprints as unique as their individual experiences in the womb. What makes this fact particularly intriguing is that we have normalized the idea that identical twins are indistinguishable in most ways. Yet fingerprints remain one of the most reliable biological markers for telling them apart, a reality that defies our intuitive expect. Your left lung is notably smaller than your right lung, a fundamental asymmetry in human respiratory anatomy that most people never consciously acknowledge despite spending their entire lives with this imbalance residing within their chest cavity. The left lung, which occupies the left side of your thoracic space, is approximately 10 to 15% smaller than its counterpart on the right side, a size difference that exists because your heart requires substantial real estate within the mediastinum, that central compartment of your chest where vital organs reside. Because your heart is positioned slightly leftward and tilts toward the left side of your body, it necessarily encroaches upon the space that might otherwise be available for your left lung to expand to its full potential, creating an indentation or concavity on the medial surface of that lung where it must accommodate the organ responsible for circulating your blood. This anatomical arrangement represents a remarkable compromise that your body has evolved to maintain, wherein the critical function of cardiac function takes spatial precedence, and your respiratory system simply adapts by developing a smaller chamber on that side while compensating with increased efficiency in gas exchange. The psychological mechanism that allows this fact to remain relatively obscure in our collective consciousness relates to the fact that we rarely, if ever, think about the internal geography of our bodies unless something goes wrong. And since this size differential is completely normal and causes no dysfunction whatsoever, it never enters our awareness or becomes a subject of casual conversation. We tend to imagine our internal organs as symmetrical mirror images of one another, operating in perfect bilateral balance, yet the reality of human anatomy is far more pragmatic and asymmetrical than our intuitive mental models suggest. For decades, the appendix was dismissed as a vestigial remnant of our evolutionary past, a useless tube of tissue lingering in the lower right abdomen with no apparent purpose beyond occasionally becoming inflamed and requiring surgical removal. Yet modern scientific research has fundamentally challenged this assumption, revealing that the appendix actually serves a significant immune function within the body's complex defense system. The appendix contains a substantial amount of lymphoid tissue, which produces antibodies and houses beneficial bacteria that play crucial roles in maintaining digestive health and bolstering immune responses. This discovery emerged gradually as researchers employed increasingly sophisticated imaging and cellular analysis techniques, examining the composition of tissue samples and tracking immune cell activity within appendiceal structures. They found that the appendix acts as a reservoir for beneficial gut bacteria, preserving a diverse microbial population that can replenish the intestinal tract if the normal bacterial community becomes depleted by illness or antibiotics. Furthermore, the lymphoid follicles within the appendix contribute to the production of immunoglobulin A, a critical antibody that protects the mucous membranes lining the digestive tract from harmful pathogens. The psychological persistence of the appendix misconception reflects how entrenched certain medical narratives become once they enter public consciousness, as generations of physicians were trained under the assumption of appendiceal uselessness. Even after evidence accumulated suggesting otherwise, the cultural memory of the appendix as an evolutionary throwaway remained remarkably resilient, requiring years of careful scientific communication to shift public understanding. Have you ever noticed that moment when your body seems to deliberately open your mouth wide, stretch your jaw, and inhale deeply, often at the most inconvenient times during meetings or quiet moments when you're trying to stay alert and engaged? This involuntary action, which we call yawning, has long been associated with drowsiness and fatigue, yet emerging scientific research suggests that yawning serves a far more sophisticated purpose than simply indicating that you need sleep. According to researchers who have studied this phenomenon extensively, yawning actually functions as a thermoregulatory mechanism, meaning your brain initiates yawning to cool itself down when it begins to overheat. The mechanism works through a process where the deep inhalation of air during a yawn, combined with the stretching of the jaw muscles, and the circulation changes in the face and neck region, allows cool air to flow through your nasal passages and into your brain tissue, effectively lowering your core brain temperature when it rises above optimal levels. When your brain becomes too warm, whether from intense cognitive activity, stress, or environmental heat, your body recognizes this as a signal that cognitive function might be compromised, and it triggers a yawn to restore your brain to its ideal operating temperature. The fascinating part of this discovery is that yawning appears to be a sophisticated biological cooling system that has been operating within us for millions of years, yet we have largely dismissed it as nothing more than a sign of boredom or sleepiness. This misunderstanding has persisted so deeply in our collective consciousness that we continue to suppress yawns in social situations, trying to hide them as if they are somehow impolite or indicative of disinterest, when in reality our body is simply performing essential maintenance on one of its most vital organs. When you step into a cold room or feel a sudden chill run down your spine during a frightening moment, your skin responds with small, raised bumps that seem to appear almost instantaneously across your arms and legs, a phenomenon we commonly refer to as goosebumps or gooseflesh. This involuntary physiological response occurs when tiny muscles at the base of each hair follicle, called erector pili muscles, contract in response to cold temperatures, fear, or intense emotions, pulling the hair upright and creating those characteristic bumps across the skin's surface. From an evolutionary perspective, this response made considerable sense for our distant primate ancestors, who were covered in far more body hair than modern humans, because when these muscles contracted across their entire bodies, the hair would stand on end, making them appear larger and more threatening to potential predators, which could potentially discourage an attack or warn other members of their social group of danger. Additionally, the trapping of air between raised hairs would have provided enhanced insulation in cold environments, helping to maintain body temperature during periods of exposure. However, modern humans possess relatively sparse body hair compared to our evolutionary ancestors, which means that goosebumps have become largely ineffective at either making us appear more intimidating to threats or providing any meaningful thermal insulation in response to cold exposure. Despite this fundamental loss of function, our bodies continue to produce goosebumps with the same automatic intensity and reliability, as if the response still served its original protective and thermoregulatory purposes, demonstrating how deeply embedded these ancient survival mechanisms remain within our nervous system. Consider the peculiar experience of hiccups, that involuntary spasming of your diaphragm that interrupts conversations, disrupts meetings, and causes momentary embarrassment in quiet spaces. Your diaphragm, the muscular sheet beneath your lungs responsible for breathing, suddenly contracts repeatedly without your conscious control, forcing air into your vocal cords and creating that distinctive sound we have named the hiccup. Most people experience hiccups multiple times throughout their lives, and yet scientists have conducted extensive research demonstrating that hiccups serve absolutely no biological function whatsoever in modern human physiology. Unlike sneezing, which clears nasal passages, or coughing, which expels irritants from airways, hiccups accomplish nothing measurable for your health or survival. The mechanism occurs when the phrenic nerve, which controls the diaphragm, becomes irritated or overstimulated, typically by eating too quickly, consuming carbonated beverages, or sudden temperature changes in the stomach. Your body then initiates this reflex action that persists from our evolutionary past, a leftover from our amphibious ancestors who used similar muscle contractions during their transition from water to land millions of years ago. Yet in humans today, this reflex has become entirely vestigial and pointless, providing no advantage to our respiratory system or digestive processes. What remains fascinating is how normalized hiccups have become in human experience despite their absolute uselessness. We have developed countless folk remedies and home treatments to stop hiccups, from holding our breath to drinking water upside down, perpetuating the notion that they are somehow worth eliminating. We accept them as simply part of being human, an odd quirk of our biology that persists without reason or benefit. Every night, your brain enters a peculiar state of consciousness where narratives unfold with seemingly boundless creativity and logic-defying sequences that somehow feel entirely real in the moment. And this remarkable phenomenon occurs predominantly during the rapid eye movement phase of sleep, a stage of the sleep cycle that scientists have thoroughly documented and studied for decades. During REM sleep, your eyes dart back and forth beneath closed eyelids, while your brain exhibits electrical activity patterns remarkably similar to those observed during waking hours. Yet your body remains nearly paralyzed, unable to act out the vivid scenarios playing across your mind. And it is during these windows of neurological intensity that the vast majority of memorable dreams take place. With dreams becoming progressively more elaborate and emotionally charged as the night advances, and your brain cycles through multiple REM periods of increasing duration. The mechanism underlying this phenomenon involves the activation of certain brain regions responsible for emotion, memory, and visual imagery, while simultaneously suppressing the areas associated with rational thought and logical reasoning, which explains why dreams can contain impossible physics, absent people who are somehow also present, and time sequences that collapse into one another without any sense of incongruity to the dreaming mind. Yet despite the scientific clarity surrounding this process, and despite the extensive research documenting that REM sleep is indeed when dreams predominantly occur, many people continue to believe that dreams happen throughout all stages of sleep equally, or they maintain the misconception that only certain types of people dream, or that dreams only occur toward morning, persisting in these inaccurate beliefs, even when presented with straightforward evidence about sleep architecture and brain activity monitoring. As if the simple and elegant truth about DRIA. It might seem counterintuitive that your brain would be more active while you're sleeping than when you're awake, yet neuroscience has revealed something quite remarkable about the nocturnal workings of your mind during rest. When you enter into the rapid eye movement stage of sleep, commonly known as REM sleep, your brain demonstrates levels of neural activity that are comparable to or even exceed the activity levels you experience during waking hours, despite the fact that your body remains relatively immobilized and your conscious awareness has essentially disconnected from external stimuli. During this stage, your brain waves display patterns similar to those observed during focused attention and alertness in the daytime, with widespread activation occurring across multiple regions including the cortex, the limbic system, and other critical neural networks. The mechanism behind this phenomenon relates to the essential functions that REM sleep serves for cognitive consolidation and emotional processing. As your brain works intensively to organize memories, process emotional experiences, integrate new information into existing knowledge structures, and engage in the vivid dream sequences that characterize this sleep stage. Your neurons fire with remarkable frequency and complexity during these periods, creating intricate neural patterns that support learning, creativity, and psychological well-being, which is why disrupting REM sleep can have significant consequences for your mental and emotional health. Despite understanding these facts through decades of sleep research and brain imaging technology, most people continue to believe that sleep is simply a state of mental shutdown and reduced activity, perpetuating the cultural narrative that productivity and consciousness are synonymous with brain function, when in reality, some of your most important neural work happens while you lie still and unconscious, fundamentally challenging O. Consider the remarkable phenomenon of returning to an activity you haven't performed in years, perhaps learning to ride a bicycle as a child and then stepping onto one again as an adult, only to discover that your body remembers exactly what to do without conscious instruction or deliberate thought. Your muscles seem to retain a kind of memory, allowing you to execute complex motor patterns with surprising accuracy despite the passage of considerable time since you last practiced these movements. When you first learned to ride that bicycle, you engaged in repetitive practice that required intense concentration and cognitive effort. But after sufficient repetition, the movements became automatic and fluid, requiring no active thinking whatsoever. The remarkable aspect of this phenomenon is that neuroscientists have discovered the memory doesn't actually reside within the muscles themselves, but rather in the neural pathways of your brain and spinal cord, where repeated motor patterns create stronger synaptic connections that essentially encode the sequence of muscular contractions needed for the task. Yet we persist in calling this phenomenon muscle memory, a linguistically accurate but neurologically misleading term that has become so deeply embedded in our understanding of physical skill development that we continue to use it reflexively without questioning its scientific accuracy. The misnomer persists because the sensation feels as though the muscles themselves are remembering and responding, since the execution happens so automatically, and the muscles are indeed the instruments performing the remembered action, even though they are merely following instructions from neural structures that have been fundamentally rewired by repetition. This demonstrates how readily we accept intuitive but inaccurate explanations for our own bodily experiences, simply because the terminology feels right and matches our subjective perception of what's. Your tongue, that remarkable muscular organ constantly working within your mouth, is home to thousands of specialized sensory cells that allow you to experience the complex flavors of the foods and beverages you consume throughout your life. And what most people do not realize is that these taste buds, the tiny sensory structures responsible for detecting sweet, salty, sour, bitter, and umami sensations, are not permanent fixtures, but rather undergo a continuous cycle of renewal and regeneration. Every single week, your body systematically replaces the taste receptor cells that line your tongue, with old cells dying and new cells being generated to take their place, meaning that the taste buds you had 7 days ago are quite literally not the same taste buds you have today, and this process continues relentlessly throughout your entire life from childhood into old age. The mechanism behind this remarkable regeneration lies in the structure of the taste bud itself, which is composed of multiple specialized cells grouped together in small papillae scattered across the surface and sides of your tongue. And these sensory cells have a naturally limited lifespan of approximately 1 to 2 weeks before they become exhausted and are replaced by fresh cells emerging from stem cells nestled within the taste bud tissue. This constant cellular turnover serves an important biological purpose because taste receptor cells are exposed to extreme conditions including hot foods, cold beverages, acidic substances, and mechanical friction from chewing, which causes inevitable wear and tear that would render them ineffective if they were not regularly refreshed. Despite this being a fundamental and continuous biological process happening inside your body right now, most people go through their entire lives completely unaware of this weekly regeneration, never contemplating the fact that their taste buds are being systematically replaced week after week. Consider the moment when you encounter a fragrance you haven't experienced in years, perhaps the distinctive scent of your grandmother's perfume or the particular smell of a childhood home, and suddenly you are transported back through time with vivid clarity, remembering not just the person or place, but the emotions and sensations associated with that moment with remarkable precision and intensity. This phenomenon, which feels almost magical in its immediacy and power, is actually rooted in the unique neurological pathway that olfactory information takes through the brain, a journey that differs fundamentally from how we process other sensory experiences. When scent molecules enter your nasal cavity, they bind to olfactory receptors that send signals directly to the olfactory bulb, a structure located at the base of your brain that maintains direct connections to the limbic system, particularly to areas known as the amygdala and hippocampus, regions critically involved in emotion processing and memory formation, respectively. This direct neural route means that smell bypasses the thalamus, the sensory relay station that processes vision, hearing, and touch, creating an exceptionally intimate and immediate connection between odor and memory that other senses do not possess. The result is that scents become powerfully encoded within emotional and autobiographical memories, so that a single whiff can unlock entire sequences of remembrance with an emotional resonance that seeing a photograph or hearing a song cannot quite replicate. What makes this phenomenon particularly remarkable is how thoroughly normalized this experience has become in human culture, how we accept without question that smell possesses this almost supernatural ability to resurrect the past, incorporating it into our literature and art and casual conversation as though it were simply an ordinary fact of existence rather than a genuinely extraordinary feature of how our brain. Consider for a moment the experience of a musician who can listen to a single note played on a piano and immediately identify it as a C sharp or an F natural without any reference tone to compare it against. A seemingly supernatural ability that has fascinated both scientists and laypeople for centuries. Yet the reality is that only about 1 in 10,000 people possess what we call absolute pitch or perfect pitch, a neurological phenomenon that allows individuals to recognize or produce musical notes by memory alone. The mechanism behind perfect pitch appears to involve a unique combination of genetic predisposition and early childhood musical training during a critical developmental window, typically before the age of 6 or 7, when the brain demonstrates remarkable plasticity in forming associations between sound frequencies and their corresponding labels. Much like learning a language during infancy creates permanent neural pathways that persist throughout life. Research suggests that those with perfect pitch have measurably different brain structures, particularly in regions associated with auditory processing and language, and neuroimaging studies have shown that their brains activate in distinct patterns when hearing musical tones compared to individuals without this ability, indicating that perfect pitch represents a genuine difference in neural organization rather than simply superior musical training. What proves particularly fascinating is that despite the existence of perfect pitch, the vast majority of professional musicians and even virtuosos who have dedicated their entire lives to music do not possess it, suggesting that perfect pitch, while remarkable, is not actually necessary for musical excellence or even for achieving the highest levels of musical performance. Yet we continue to regard it as a kind of gold standard ability that somehow validates musical genius, when in reality most accomplished musicians navigate. Imagine a world where the number 5 tastes like copper, where the letter B appears in shades of crimson, or where hearing the sound of a trumpet triggers the sensation of touching velvet against your skin. For some people, this is not imagination at all, but rather their lived reality, a condition known as synesthesia, which represents a genuine neurological phenomenon where stimulation of one sensory pathway leads to automatic, involuntary experiences in another sensory pathway. When researchers began studying synesthesia in depth, using modern neuroimaging technologies like functional magnetic resonance imaging, they discovered that the brains of synesthetes show measurable differences in connectivity patterns, with increased neural crosstalk between regions that typically process different sensory modalities, suggesting that synesthesia arises from actual structural and functional variations in how the brain wires itself during development. The condition appears to stem from either increased connectivity between sensory processing regions or reduced pruning of neural connections that typically diminish after infancy, meaning that most people naturally eliminate these cross-sensory links as they mature, but synesthetes retain or develop stronger connections between areas like the visual cortex and auditory cortex, or between taste processing centers and language regions. Remarkably, synesthesia is not a hallucination or a learned association, but rather an automatic response that synesthetes cannot control or suppress, and it remains consistent throughout their lives, with the same stimulus always producing the same sensory experience, demonstrating the deeply embedded neurological nature of the phenomenon. What makes synesthesia particularly fascinating from a scientific perspective is that it reveals how the brain's fundamental architecture is not as rigidly compartmentalized as we once believed, and while we have normalized the Consider a patient suffering from chronic pain who receives what they believe to be a powerful new medication, only to experience significant relief within hours, yet the pill they swallowed contained nothing but sugar and inert ingredients. This phenomenon, repeated countless times across rigorous clinical trials and medical practice, demonstrates something that challenges our fundamental understanding of the mind and body relationship. The placebo effect is not merely psychological theater or self-deception, but rather a measurable neurobiological response where the brain's expectation of healing actually triggers genuine physiological changes that reduce pain, lower blood pressure, improve immune function, and even alter brain chemistry through the release of endogenous opioids and other neurotransmitters. When someone receives a placebo while being told it will help them, their brain doesn't simply ignore reality, but instead activates neural pathways associated with healing and recovery, creating real biological effects that can be observed through brain imaging and biochemical markers. The mechanism operates through several interconnected processes, including classical conditioning, where previous experiences of healing become associated with environmental cues and rituals, expectancy, where the brain's prediction of improvement literally shapes how sensory information gets processed and interpreted, and social context, where the confidence and authority of a healthcare provider influences the patient's neurological response. What makes this phenomenon particularly fascinating is that the placebo effect persists and remains powerful even when patients are fully informed that they are receiving a placebo with no active ingredients, suggesting that conscious knowledge of the deception does not eliminate the brain's capacity to generate authentic healing responses. We have long understood the power of the placebo effect, where a person experiences genuine improvements in their condition simply because they believe they have received effective treatment, even when that treatment is chemically inert or inactive in any meaningful way. However, what remains far less discussed in popular conversation is the mirror image of this phenomenon, the nocebo effect, which demonstrates that our minds possess an equally powerful capacity to create harm and suffering through negative expectations and beliefs alone. The nocebo effect occurs when a person experiences negative health outcomes, increased symptoms, or genuine physiological decline, not because of any direct biological mechanism, but rather because they expect to feel worse, believe they will suffer, or have been told that a particular substance or situation will cause them harm. In clinical research studies, patients who are explicitly warned about potential side effects from a medication they are about to receive frequently report experiencing those exact side effects, even in cases where the substance administered is actually a placebo with no pharmacologically active ingredients whatsoever. Beyond the laboratory, nocebo effects manifest in everyday life when individuals who learn that their neighborhood has poor air quality begin reporting increased respiratory symptoms, or when people who discover their drinking water contains trace elements of a substance they have heard is dangerous suddenly develop gastrointestinal distress that has no pathological basis. The mechanism underlying this effect operates through the same neurobiological pathways that enable the placebo effect to function, involving the complex interplay between our expectations, our nervous system, and our body's actual physiological responses, whereby our conscious beliefs and unconscious fears can literally instruct our bodies to produce pain, inflammation, and malfunction. Imagine two particles that have been created together and then separated across vast distances, perhaps on opposite sides of the universe itself. And yet when you measure a property of one particle, the other particle instantaneously responds and aligns its properties accordingly, as though they are communicating faster than the speed of light, which Einstein himself famously called spooky action at a distance, because he found the concept so profoundly unsettling and counterintuitive to everything we understand about how the universe operates. This phenomenon, known as quantum entanglement, has been mathematically proven and experimentally verified countless times by physicists across the globe, demonstrating that once two particles become entangled through their shared quantum state, measuring one particle's spin or polarization instantly affects the other, no matter the separation between them. The reason this concept feels so deeply wrong to our logical minds is that it seems to violate the fundamental principle established by relativity theory that nothing can travel faster than light. And yet here we have information or correlation that appears to instantaneously link two separate locations in space, creating a paradox that our everyday experience of cause and effect cannot accommodate. Physicists have spent decades grappling with the interpretation of this reality, proposing various explanations, such as the idea that no usable information actually travels between the particles, or that the universe itself contains hidden variables we haven't discovered, or that our understanding of time and causality at quantum scales simply operates under different rules than we've assumed. What makes quantum entanglement particularly fascinating is that despite its strangeness, and despite the fact that we still don't fully understand the mechanism behind it, scientists have not only accepted it as real, but have begun harnessing it for. Consider for a moment the everyday experience of sunlight streaming through your window, warming your skin and illuminating the room around you. And yet this radiant energy that we perceive so vividly and feel so tangibly carries absolutely no mass whatsoever. A concept that defies our intuitive understanding of physical reality, because throughout our entire lives, we have been conditioned to believe that anything capable of exerting force, traveling through space, or interacting with matter must possess some fundamental substance or weight, and yet light remains massless despite being one of the most powerful and influential forces in the universe. The reason this truth unsettles us so profoundly is rooted in our evolutionary heritage. As our ancestors developed sensory systems that evolved to detect and interact with objects that possess mass and occupy space, and this foundational framework became hardwired into our cognitive architecture, making it nearly impossible for our intuition to grasp the idea that something can be perfectly real and measurable and consequential while simultaneously having zero mass. And when physicists revealed through mathematical equations and experimental observation that photons, the fundamental particles composing light, travel at the speed of light precisely because they have no mass and therefore experience no resistance from the fabric of spacetime itself, this discovery violated every assumption our brains automatically make about how the physical world operates. What makes this fact even more remarkable is that despite light having no mass, it does carry momentum and can exert radiation pressure on objects, meaning that this massless phenomenon can actually push physical matter across distances, and this apparent paradox persists in our collective consciousness as something we accept intellectually while remaining emotionally unable to truly internalize, much in the way we accept many counterintuitive psi. Consider for a moment the profound equation that emerged from Albert Einstein's theory of special relativity in 1905, a simple mathematical relationship that fundamentally altered our understanding of the physical universe and the nature of matter itself, expressing that energy and mass are interchangeable through the constant speed of light, yet despite its revolutionary implications and nearly universal recognition. Most people cannot truly comprehend what this equation actually means, or why it matters in any practical sense. The mechanism behind this widespread incomprehension lies in the abstract nature of the concept itself, for the equation describes a relationship between three quantities that exist at the boundary of human intuition, where mass represents the amount of matter in an object, energy represents the capacity to do work or create change, and the speed of light, approximately 300,000 kilometers per second, serves as a conversion factor of almost incomprehensible magnitude. When we square this already staggering speed and multiply it against even a tiny amount of mass, we arrive at an energy quantity so enormous that a single kilogram of matter contains as much energy as thousands of tons of TNT, a fact that defies our everyday experience where objects around us seem inert and stable, possessing no obvious energetic potential whatsoever. The psychological mechanism that allows this incomprehension to persist is our reliance on evolutionary intuition, for our brains develop to understand the world at human scales where relativistic effects remain invisible, where a cup of coffee seems like just a cup of coffee and not a repository of sufficient energy to power cities. Yet we have normalized this bewilderment by treating the equation as a cultural artifact rather than a lived understanding. Repeating the symbols and venerating Einstein's genius without actually integrating the truth it rep. Most people assume that antimatter exists only in science fiction or in the carefully controlled environments of particle accelerators where physicists spend millions of dollars creating exotic particles. Yet the reality is that antimatter is being produced naturally in Earth's atmosphere at this very moment, continuously and constantly, through the interaction of cosmic rays with our upper atmosphere. When high-energy cosmic rays strike nitrogen and oxygen molecules in the stratosphere, they create showers of secondary particles, and among these particles are positrons, which are the antimatter counterparts of electrons, possessing identical mass but opposite electrical charge. And these positrons are generated in quantities far larger than most people would ever suspect or consider possible. The mechanism behind this seemingly impossible phenomenon involves the conversion of kinetic energy into matter through the fundamental equations of physics, where the tremendous energy of cosmic ray collisions can spontaneously transform into particle-antiparticle pairs, following the mathematical relationships that Einstein established over a century ago. Yet despite this being a well-documented scientific fact established through decades of atmospheric measurements and observational data, most people remain entirely unaware that antimatter precipitation is literally falling through the sky above their heads every single day. What makes this concept so difficult for people to internalize is the psychological disconnect between our intuitions about the nature of matter itself and the actual quantum mechanical reality that governs the subatomic world, since we are trained from early childhood to think of matter as solid, permanent, and singular, rather than as something that can be created and destroyed in particle pairs, existing in a dynamic equilibrium with energy itself. When we think of black holes, our minds conjure images of cosmic voids vast emptiness, regions of absolute nothingness where matter simply vanishes into oblivion. But the reality of what black holes actually are tells a fundamentally different story. A black hole is not a hole at all, but rather one of the most densely packed objects in the entire universe, a region of spacetime where gravity has become so incredibly intense that it warps the fabric of reality itself into something almost incomprehensible. When a massive star reaches the end of its life and collapses, its matter doesn't disappear into some kind of spatial opening or void, but instead compresses down into an infinitely small point of infinite density called a singularity, surrounded by an event horizon which is merely the boundary beyond which no light or matter can escape. The reason we perceive black holes as holes stems from our intuitive misunderstanding of how gravity works at extreme scales, combined with the visual representations scientists use to explain them, which often show them as dark regions of emptiness surrounded by swirling material. Our brains struggle to conceptualize objects of unimaginable density, and instead interpret the description of something from which nothing escapes as something that must be a void or opening, rather than a region of compressed matter so tightly bound together that its gravitational pull is absolute. This misconception persists throughout popular culture, science fiction, and casual conversations about space, despite decades of scientific communication attempting to clarify the distinction between a hole and an extraordinarily dense object, suggesting that the metaphor of the hole is simply too intuitive, too visual, and too deeply embedded in how we naturally think about missing things and empty spaces to be easily displaced by the more accurate but abstract reality of what these objects truly represent. Imagine standing in an infinitely vast cosmos where not only are galaxies moving away from each other, but the rate at which they're moving away is continuously increasing, accelerating outward at speeds that defy our most intuitive understanding of how the universe should behave. In 1998, astronomers observing distant supernovae made an observation so counterintuitive that it fundamentally challenged our comprehension of cosmic mechanics. The expansion of the universe is not slowing down as gravity should theoretically cause it to do, but rather it is speeding up, driven by something scientists have termed dark energy, which comprises approximately 68% of all matter and energy in existence, yet remains almost entirely mysterious and unobservable to our instruments. The mechanism behind this acceleration appears to stem from a property of space itself, where the vacuum of nothingness between galaxies possesses energy that actively pushes matter apart, causing the cosmic expansion rate to increase with time rather than decrease as conventional physics would predict. This phenomenon has been confirmed through multiple independent lines of evidence, including observations of supernovae brightness, measurements of the cosmic microwave background radiation, and the distribution patterns of galaxy clusters across billions of light years, all pointing consistently toward this same accelerating expansion. What makes this particularly challenging to internalize is that our brains evolved to understand a universe operating under classical mechanics, where friction slows things down and gravity pulls things together. Yet here we find ourselves inhabiting a cosmos where the very fabric of space is being stretched apart at an ever-increasing rate, with no friction to slow it and a mysterious force completely overwhelming gravitational attraction on the largest scales imaginable. Imagine standing in a vast cosmic library where approximately 85% of the books on the shelves are completely invisible to your eyes, yet their weight and gravitational presence can be detected through careful measurement and mathematical calculation. This is the reality of dark matter, a mysterious substance that pervades the universe in quantities so enormous that it far outweighs all the visible matter we can actually see, including stars, planets, galaxies, and everything composed of atoms that emit or reflect light. Scientists have determined, through decades of astronomical observations and gravitational measurements, that dark matter must exist because galaxies rotate at speeds that would cause them to fly apart if only the visible matter we observe were actually present to hold them together through gravitational force. The phenomenon occurs because dark matter neither emits nor absorbs light, making it completely invisible to every telescope we have ever constructed, from radio telescopes to optical instruments to X-ray detectors, yet its gravitational effects are unmistakably present throughout the cosmos. The human mind struggles with this reality because we have evolved to trust our visual perception above all other forms of information. So being told that the vast majority of the universe's matter is something we can never directly see creates a profound cognitive dissonance that contradicts our most basic instincts about how the world actually works. We have normalized this impossibility through scientific consensus and mathematical certainty, accepting that dark matter must be real despite remaining fundamentally undetectable. And this acceptance represents one of modern science's most humbling admissions that the observable universe we perceive is merely the visible tip of an incomprehensibly larger cosmic iceberg whose true composition remains one of the deepest mysteries in all of physics. Imagine standing in the vast darkness of night, gazing up at the infinite cosmos stretching endlessly in every direction, and consider that nearly 70% of all the energy and matter that comprises the universe is something we cannot see, cannot touch, and cannot directly measure in any conventional sense. This mysterious phenomenon, which scientists call dark energy, appears to fill the entirety of space itself, permeating the vacuum between galaxies and stars with an invisible force so profound that it is actually accelerating the expansion of the universe at an ever-increasing rate. When astronomers first made observations of distant supernovae in the 1990s, they expected to find that the expansion of the universe was slowing down over time due to the gravitational pull of all the matter within it. Yet instead they discovered something truly bewildering. The universe was expanding faster than it should be, suggesting the presence of an unknown form of energy acting against gravity itself. The mind struggles to conceptualize what dark energy actually is because our brains evolved to understand objects and forces in the physical world around us, things we could hunt, gather, and manipulate for survival. So when confronted with an invisible, unmeasurable force that comprises most of the universe, our intuition finds no anchor point upon which to grasp its nature. We have simply accepted dark energy as an established part of our cosmological model because the mathematics works, because multiple independent observations confirm its existence, and because the scientific community has settled on this as the best explanation for the universe's accelerating expansion, even though the fundamental nature of dark energy remains one of the deepest unsolved mysteries in all of modern physics. Imagine standing on the surface of the Earth, feeling the familiar downward pull that has defined human existence since our species first became conscious of such forces, a sensation so constant and unquestioned that we rarely pause to consider what is actually occurring in the fabric of reality beneath our feet. According to Einstein's revolutionary theory of general relativity, which fundamentally transformed our understanding of the universe, gravity is not actually a force pulling objects downward in the classical sense that Newton described centuries ago, but rather the curvature of spacetime itself caused by the presence of mass and energy. When massive objects like the Earth or the Sun exist in the universe, they do not simply sit passively in empty space, but instead they bend and warp the very fabric of spacetime around them, creating curves and depressions much like a heavy ball placed on a stretched rubber sheet would create an indentation. And objects moving through this warped spacetime follow curved paths that we perceive as gravitational attraction. The reason this concept remains genuinely difficult for most people to fully internalize, despite being the accepted scientific explanation for gravity for over a century, lies in the fact that our everyday sensory experience provides absolutely no intuitive framework for understanding the geometry of spacetime itself, since we cannot directly perceive higher dimensional curvature or feel the bending of space and time around us. We experience gravity only as a directional force pushing us toward the ground, a sensation that is perfectly consistent with Newton's older framework, meaning our brains have no evolutionary reason to develop the kind of geometric intuition necessary to truly grasp how massive objects actually restructure the dimensions themselves. Consider the experience of sitting through a dentist appointment that lasts 30 minutes, and then spending 30 minutes with someone you deeply care about during a meaningful conversation, and notice how these two intervals of identical duration feel fundamentally different in your lived experience, with one stretching endlessly while the other vanishes in what feels like moments. This phenomenon, which Einstein formalized through his theory of relativity, extends far beyond our subjective perception and enters the realm of physical reality itself, where time actually does move at different rates depending on gravitational fields and velocity, meaning that an astronaut orbiting Earth at tremendous speeds ages measurably slower than people remaining on the surface below. A scientifically verified fact that challenges our intuitive understanding of time as a universal constant that flows uniformly for all observers regardless of their circumstances. Our brains interpret time through the lens of attention and emotional engagement, where concentrated focus on a task makes minutes feel compressed, while boredom stretches seconds into perceived eternities. And this psychological mechanism exists because our nervous systems encode memories based on the richness of experience rather than objective chronological measurement, causing our retrospective sense of duration to diverge wildly from clock time. We have normalized this relativity of time despite its counterintuitive nature by relegating it to the realm of physics textbooks and theoretical discussions, allowing ourselves to forget that time genuinely behaves differently under extreme conditions, and that our everyday perception of it is merely one narrow slice of a far more complex reality, where duration itself becomes flexible and malleable according to the observer's frame of reference and environmental conditions. When you find yourself sitting in traffic on a crowded highway during rush hour, watching the minutes crawl by with agonizing slowness as you inch forward at a pace that barely qualifies as movement, time seems to stretch into an almost unbearable expanse. And yet the moment you merge onto an open freeway where you can accelerate to a steady cruising speed, something remarkable happens to your perception of duration. The very same 30-minute journey that felt interminable in congestion now seems to vanish almost instantly, as though the increased velocity has somehow compressed the temporal experience itself. And this sensation is not merely psychological, but is actually rooted in how our brains process information and perceive the passage of time. When we move at higher speeds, our visual field changes more rapidly, our sensory input increases significantly, and the number of distinct moments we consciously register decreases because there is simply less time for our attention to linger on individual instances between one location and another. The brain, in its fundamental architecture, measures time not by the ticking of a clock, but by the number of novel experiences and distinct perceptions it encounters, which means that faster movement results in fewer perceived moments and therefore a collapsed sense of how long something actually took. This phenomenon reveals itself in countless everyday situations beyond driving, such as when you take a leisurely walk through a familiar neighborhood and feel as though time expands with every tree and sidewalk crack you notice, whereas a swift jog through the same route seems to evaporate almost without your awareness. We have largely come to accept this distortion as normal rather than remarkable, integrating it seamlessly into our understanding of how consciousness works, and yet it remains genuinely astonishing that the simple act of moving faster through space can fundamentally alter our. In 1935, an Austrian physicist named Erwin Schrödinger proposed a hypothetical scenario designed to illustrate the peculiar nature of quantum mechanics and how its principles seemed absurd when applied to the everyday world we inhabit. Imagine, he suggested, that you place a living cat inside a sealed, opaque box along with a radioactive atom, a Geiger counter, a vial of poison, and a hammer mechanism that will break the vial and kill the cat if the atom decays and triggers the counter. Once the box is sealed, you have no way of observing what is happening inside, and according to the mathematics of quantum mechanics, the atom exists in what is called a superposition state, meaning it is simultaneously both decayed and undecayed until someone opens the box and observes the result. The thought experiment raises an unsettling question. If the atom's state is indeterminate until observed, does that mean the cat inside is both alive and dead at the same time? The mechanism that makes this paradox so intellectually challenging is rooted in the Copenhagen interpretation of quantum mechanics, which suggests that observation itself causes the collapse of quantum probability waves into definite states, a principle that feels deeply counterintuitive when applied to macroscopic objects like cats rather than invisible particles. We have come to accept this peculiar aspect of physics despite its logical impossibility in our everyday experience, teaching it in universities and discussing it casually in popular culture as though a cat could genuinely exist in two mutually exclusive states simultaneously. What persists is not the idea that cats are actually in superposition, but rather our collective tolerance for embracing deeply paradoxical concepts as fundamental truths about reality, demonstrating our capacity to hold contradictory ideas about the nature of existence without demanding complete resolution. The observer effect is a phenomenon discovered in quantum mechanics, where the act of measuring or observing a particle fundamentally changes its behavior and properties, as if the particle somehow knows it is being watched and responds by altering its state in measurable ways. When scientists designed experiments to track the path of an electron through a double-slit apparatus, they found that electrons behaved like particles when observed, passing through one slit or the other, yet when no one was looking they behaved like waves, passing through both slits simultaneously and creating an interference pattern that should not exist if they were truly particles. This counterintuitive reality revealed something profound about the nature of existence itself, suggesting that observation is not a passive act of simply recording what is already there, but rather an active participation in creating reality at the quantum level, where measurement tools interact with the very systems they measure, fundamentally altering outcomes. The psychological mechanism behind why this concept is so difficult to accept stems from our everyday experience, where we expect observation to be neutral and non-intrusive, a simple act of gathering information without changing the thing being observed. Yet at the quantum scale, this comfortable assumption completely breaks down. We have somehow normalized this bizarre truth by building it into the foundation of modern physics and quantum theory, accepting that at the smallest scales of reality, consciousness and measurement are inseparably linked to physical outcomes, creating a philosophical puzzle that physicists have debated for nearly a century without reaching complete consensus on what it truly means. Some interpretations suggest that the observer effect implies a participatory universe where reality remains fundamentally indeterminate until measured, while others argue it merely reflects the unavoidable int. At the quantum level, where atoms and electrons dance in the realm of impossibly small scales, there exists a fundamental limitation that has puzzled physicists and philosophers for nearly a century, a principle so counterintuitive that it challenges our most basic assumptions about the nature of reality itself. Werner Heisenberg discovered that you cannot simultaneously know both the precise position and the precise momentum of a particle with absolute accuracy, and the more precisely you measure one of these properties, the less precisely you can know the other, creating an irreducible uncertainty that seems to be woven into the fabric of existence itself. When a scientist attempts to locate an electron by bombarding it with light particles called photons, the very act of measurement disturbs the electron's momentum, pushing it and changing its velocity in ways that cannot be predicted or controlled. So the observer becomes inevitably entangled with the observed, fundamentally altering what is being measured. This is not merely a limitation of our current instruments or techniques that future technology might overcome, but rather a mathematical truth embedded in quantum mechanics itself, suggesting that reality at its most fundamental level does not exist in a definite state until it is observed and measured. What persists in our collective consciousness is the profound strangeness of this principle, the way it inverts our everyday experience where we expect to measure things without changing them, where looking at something should not alter what we are looking at. Yet the quantum world operates under entirely different rules that seem to suggest that uncertainty and indeterminacy are not flaws in our understanding, but rather core features of how the universe actually functions at its deepest level. Consider the fundamental nature of light and matter at the smallest scales of reality, where quantum mechanics reveals something so counterintuitive that it challenges the very foundation of how we understand the physical world. When scientists observe light or electrons, these entities behave as particles, possessing definite positions and velocities that can be measured with precision. Yet when those same scientists look away or fail to observe them directly, these entities behave as waves, spreading out through space and exhibiting interference patterns that could only be produced by something undulating through a medium. This is wave-particle duality, and it means that the fundamental building blocks of existence are neither purely particles nor purely waves, but rather something that exists in a strange superposition between both states, shifting its behavior based on how we choose to examine it. The mechanism underlying this phenomenon relates to the act of observation itself, for when we measure the position of a particle using photons or other detection methods, we necessarily impart energy that forces the entity into a particle-like state. Whereas when we allow these entities to propagate without direct measurement, the mathematical descriptions that govern their behavior reveal wave-like characteristics and probability distributions. What makes wave-particle duality so persistently difficult to accept is that it violates our intuitive understanding of reality as something independent and fixed, existing in definite states regardless of whether anyone is looking at it. We have normalized this impossibility through decades of technological success, building lasers and semiconductors and quantum computers based on accepting wave-particle duality as simply the way nature operates at its most fundamental level, even though no human can truly visualize what a photon or electron actually is between these two contradictory descriptions. Imagine a particle trapped behind a barrier so high that it should never be able to escape, yet somehow it does anyway, passing through solid walls as though they were merely suggestions rather than physical obstacles. And this is not science fiction, but rather established quantum mechanical reality that has been measured countless times in laboratories around the world. Quantum tunneling occurs when subatomic particles like electrons or alpha particles encounter energy barriers that classical physics says they should not be able to penetrate. Yet the mathematical descriptions provided by quantum mechanics reveal a fundamental truth about reality at the smallest scales, which is that particles exist in a state of probability rather than certainty. And this probabilistic nature means that there is always a non-zero chance that a particle will appear on the opposite side of a barrier despite lacking the energy needed to climb over it. The mechanism underlying this phenomenon emerges from the wave nature of matter itself, as described by the Schrödinger equation, which treats particles not as solid little balls, but rather as probability waves that can extend across space. And when such a wave encounters a barrier, it does not simply stop, but rather continues decaying exponentially on the other side of the barrier, creating a tail that means the particle could theoretically be found beyond where it should be trapped. What makes quantum tunneling particularly remarkable is that it is not rare or exotic, but rather a constant feature of how the universe operates at quantum scales, and it is essential to the functioning of nuclear fusion in stars, the operation of tunnel diodes in electronics, the process of radioactive decay, and indeed the very stability of atoms themselves, yet despite being proven through countless experiments and being built into the infrastructure of modern technology. Many people find it impossible to accept that par. In the quantum realm, particles exist in a state of profound uncertainty where they simultaneously occupy multiple positions, spin states, or energy levels until the moment they are observed or measured, a phenomenon so counterintuitive that even Albert Einstein struggled to accept it and famously questioned whether the moon truly exists when nobody is looking at it. When we examine how superposition manifests in laboratory settings, we find that electrons can exist in multiple orbitals at once, photons can travel through multiple slits simultaneously, and quantum systems maintain this ghostly existence across all possible states in what physicists describe as a probability cloud rather than any concrete reality. And this is not merely a limitation of our measurement tools, but rather a fundamental aspect of how reality operates at its most basic level. The psychological mechanism that allows us to accept this seemingly impossible concept relies on our ability to abstract away from everyday intuition and embrace mathematical formalism as the truest description of nature, wherein the wave function becomes more real than our common sense expectations, and we gradually train our minds to accept that particles genuinely do not have defined properties until observation forces them to collapse into a single state. What makes superposition particularly remarkable is that it has been experimentally verified countless times through tests like the double-slit experiment and quantum interference patterns. Yet we continue to live in a macroscopic world where superposition never seems to apply to objects we can see, creating a strange disconnect between quantum reality and classical experience that somehow feels both impossible and completely proven simultaneously. Consider the fundamental nature of light itself, that ethereal phenomenon which has captivated human curiosity since the dawn of consciousness, and understand that photons, the discrete packets of electromagnetic energy that comprise light, travel through the vacuum of space at precisely 300 million meters per second, a velocity so immense that it forms the cosmic speed limit beyond which nothing in the universe can accelerate. This speed, denoted by the letter c in the equations of physics, represents not merely a suggestion or average velocity, but rather an absolute constant, a true invariant of nature that remains identical whether measured by an observer on Earth, on a distant star, or aboard a spacecraft hurtling through the cosmos at tremendous velocity. The photon possesses no mass, which distinguishes it fundamentally from all other known particles, and this massless property permits it to achieve and maintain this ultimate velocity without requiring infinite energy, a mathematical necessity that allows photons to traverse the vast distances between stars and galaxies, carrying information and energy across the universe in what amounts to the fastest possible method of communication and energy transfer available within our physical reality. We accept this fact with scientific certainty, yet the human mind struggles genuinely to conceptualize what such a velocity truly means, for our evolutionary psychology developed in an environment where the fastest observable phenomena moved at comparatively pedestrian speeds, and light's instantaneous appearance to our unaided senses meant that for millennia, humans believed light traveled instantaneously with no travel time whatsoever. Even after scientists like Ole Romer measured light's finite speed in the 17th century, and James Clerk Maxwell predicted this exact velocity through his equations of electromagnetism in the 19th century, we continue to experience L. Consider the profound reality that light represents the ultimate speed limit of the universe, a fundamental constraint so absolute that nothing with mass can ever reach it, let alone exceed it. When we observe light traveling through a vacuum at approximately 300,000 kilometers per second, we are witnessing the fastest phenomenon that can possibly exist in our physical reality, and this speed remains constant regardless of the observer's position or motion relative to the light source itself. This principle emerged from Einstein's theory of special relativity, which revealed that as any object with mass accelerates and approaches the speed of light, its relativistic mass increases exponentially, requiring progressively more energy to continue accelerating, making it physically impossible to achieve light speed because infinite energy would be required. The psychological mechanism that keeps us engaged with this concept, despite its abstract nature, is our tendency to treat extreme numbers and velocities as conceptual rather than deeply internalized truths. We intellectually acknowledge that nothing travels faster than light because we have been told this repeatedly in educational contexts. Yet our everyday experience never truly confronts us with this limitation, since we interact with objects moving at negligible fractions of light speed. This disconnect between intellectual acceptance and experiential understanding allows us to hold this fact in our minds almost passively, accepting it as established scientific doctrine without fully grappling with its staggering implications for causality, time, and the structure of reality itself. The fact has become so normalized in popular science discourse that we rarely pause to consider how genuinely counterintuitive and constraining this universal speed limit truly is, representing a fundamental boundary that shapes everything from particle physics to cosmology. Tachyons represent one of the most captivating and persistently intriguing concepts in theoretical physics, existing purely as mathematical constructs that have never been observed or detected in any experimental setting, despite decades of intensive scientific scrutiny and increasingly sophisticated detection methods. The concept emerged from the equations of special relativity in the 1967 when physicist Gerald Feinberg proposed particles that could theoretically travel faster than the speed of light, which would require them to possess imaginary mass and exist in a state fundamentally different from all known particles we encounter in the observable universe. The mathematics describing tachyons appears internally consistent within certain theoretical frameworks, creating an elegant logical structure that captivates physicists and lay enthusiasts alike. Yet no experiment has ever produced even a hint of evidence that such particles actually exist in reality rather than merely in the realm of mathematical possibility. What makes tachyons particularly fascinating is how they have become embedded in popular science discourse and public imagination despite their purely hypothetical status, appearing frequently in science fiction narratives and popular science articles as though they represent a known phenomenon rather than a speculative mathematical concept. The psychological mechanism driving this persistent cultural presence stems from humanity's deep fascination with paradox and the unknown, combined with the fact that tachyons emerge from the same equations that correctly describe our universe, lending them an air of legitimacy and plausibility that exceeds their actual scientific standing. We have somehow normalized the discussion of tachyons as real entities deserving serious consideration, when in fact they remain no more established than countless other theoretical particles predicted by various speculative models. Consider the peculiar reality that Einstein's equations, the very mathematical framework upon which modern physics rests, actually permit the existence of wormholes, those hypothetical tunnels through spacetime that would theoretically connect distant regions of the universe or even different universes entirely. When physicists work through the complex tensor equations of general relativity, they discover that solutions describing these exotic structures emerge naturally from the mathematics, suggesting that the laws of physics themselves do not explicitly forbid their existence. A wormhole would function as a bridge through the fabric of spacetime itself, allowing passage between two otherwise distant points in a way that could theoretically enable faster-than-light travel or access to parallel dimensions, all without violating the fundamental equations that govern gravitational fields and the curvature of spacetime. The mathematical legitimacy of wormholes arises from the fact that Einstein's field equations contain multiple valid solutions, and some of these solutions describe geometries that permit closed time-like curves and non-orientable topologies that would characterize wormhole structures. Yet despite this profound mathematical foundation, wormholes remain firmly in the theoretical realm, never observed and deeply problematic in their requirements, needing either exotic matter with negative energy density or traversable geometries that seem physically implausible to create and maintain. The persistence of wormholes in serious scientific discourse, published in peer-reviewed journals and taught in graduate physics programs, represents a remarkable acceptance of objects that may never physically exist, objects born purely from mathematical elegance rather than empirical confirmation, demonstrating how the abstract beauty of equations can command respect within scientific communities even when practical realization appears. Consider the strange mathematical frameworks that emerge from our most rigorous attempts to describe reality itself, particularly those arising from quantum mechanics and cosmological models that physicists have developed through decades of careful observation and experimentation. When scientists examine the fundamental equations governing subatomic particles, they discover that these mathematical descriptions seem to permit the existence of multiple universes existing simultaneously alongside our own, each potentially containing different versions of physical laws, different outcomes of quantum events, and perhaps even alternate versions of ourselves making different choices at crucial moments in history. The many worlds interpretation of quantum mechanics suggests that whenever a quantum event occurs with multiple possible outcomes, the universe actually splits into branches where each outcome happens in a separate reality, creating an exponentially expanding tree of parallel universes where every possibility is realized somewhere. Similarly, inflationary theory in cosmology proposes that the Big Bang may have created not just our universe, but an infinite landscape of universes, each with subtly different properties and fundamental constants, most of which remain forever beyond our ability to observe or contact. This concept persists throughout modern physics not because it has been proven true, but because the mathematics describing our universe genuinely allows for these possibilities, and physicists have found it difficult to construct consistent theories of reality that absolutely forbid such parallel universes from existing. We have come to accept parallel universes as a serious scientific concept worthy of investigation and discussion, despite the fact that we possess no direct evidence of their existence and no practical means by which we might ever detect or interact with them, speaking about this profound uncertainty as the concept of the multiverse represents one of the most profound ideas to emerge from modern theoretical physics, yet it remains fundamentally speculative and unproven, existing primarily as a mathematical consequence rather than as an established scientific fact. When physicists work through the equations of quantum mechanics and general relativity, certain solutions naturally suggest the existence of parallel universes or alternate realities operating alongside our own, each following its own physical laws and containing its own versions of matter and energy. This mathematical elegance has led many brilliant minds to take the multiverse seriously as a legitimate area of inquiry, despite the fact that we possess absolutely no empirical evidence of these other universes and no conceivable way to observe or detect them directly. The psychological mechanism at work here involves the human tendency to treat mathematical possibility as evidence of physical reality, a tendency that becomes particularly powerful when the mathematics emerges from theories that have proven remarkably accurate in other contexts. We extend trust to the equations because they have guided us toward genuine discoveries, and we unconsciously slip into treating theoretical predictions with the same confidence we reserve for observed phenomena. The persistence of multiverse discussions in popular culture and even in serious scientific discourse reveals how normalized this slip has become, how readily we accept that something which cannot be measured, observed, or tested empirically might nonetheless be considered part of our understanding of reality. Scientists themselves often speak of the multiverse with a tone of certainty that obscures its purely theoretical nature, discussing it as though it were settled physics rather than an intriguing possibility that extends beyond the boundaries of what we can ever verify through experiment or observation. When we imagine the beginning of the universe, our minds almost inevitably conjure the image of a massive explosion, a sudden violent eruption of matter and energy bursting outward into the void from some central point, expanding rapidly in all directions like a bomb detonating in the darkness of space. This mental picture has become so deeply embedded in our cultural understanding of cosmology that it feels intuitively correct, almost obvious. Yet this visualization fundamentally misrepresents what scientists actually mean when they describe the Big Bang theory. The Big Bang was not an explosion happening within space, but rather the emergence and expansion of space itself, along with all the matter and energy contained within it, a distinction so profound that it completely changes the nature of what we imagine to be occurring. In an ordinary explosion, particles fly outward from a central location into pre-existing empty space, moving away from each other at velocities determined by the force of the blast. Yet in the Big Bang, there was no pre-existing space into which matter was expanding, and there was no central location from which it erupted. Instead, space itself began to expand uniformly from an incredibly hot, dense initial state, and this expansion means that the distance between all galaxies increased together, not because they were moving through space away from each other, but because space itself was growing. This confusion persists partly because our language and visual metaphors are fundamentally limited when discussing phenomena so far removed from human-scale experience, and partly because the idea of an explosion is far more viscerally compelling and imaginable than the abstract concept of spacetime expansion itself. We have grown accustomed to accepting this imprecise terminology in popular science discussions, in documentaries, and in textbooks written for general audiences, and we rarely pause to question whether. Consider the profound discomfort that arises when we truly contemplate the absence of a center to the universe, a realization that fundamentally contradicts our most basic intuitions about how space and existence must be organized. Throughout human history, we have inhabited a world that appears to revolve around us, where the sun rises in the east and sets in the west, where the ground beneath our feet feels stationary and solid, and where everything in the sky seems to move in great arcs overhead, suggesting that Earth occupies some privileged position at the heart of creation. This geocentric worldview persisted for millennia because it matched our sensory experience so perfectly that questioning it seemed almost absurd. Yet modern cosmological observations have revealed something far stranger and more unsettling than anyone in ancient times could have imagined. The universe is not arranged like a great palace with Earth or our solar system or even our galaxy at its center, but rather it expands uniformly in all directions without any central point whatsoever, a concept that our minds struggle to grasp because we are creatures shaped by terrestrial perspective. When we look outward into space in every direction, we observe distant galaxies receding from us at speeds proportional to their distance, a pattern called Hubble expansion, and this phenomenon occurs identically for observers anywhere in the universe, meaning that no matter where you stand among the billions of galaxies, you would always perceive yourself as being at the center of expansion, even though this center does not actually exist. The psychological mechanism sustaining our resistance to this fact relies on our inability to genuinely visualize a space without a center, a space where every point is simultaneously central and peripheral, where the laws of physics operate with perfect indifference to location, and where our significance derives not from position but from O. Consider the vast cosmos stretching infinitely in all directions around us, and understand that despite the billions upon billions of stars, galaxies, and celestial bodies we observe through our telescopes and instruments, the universe is fundamentally and overwhelmingly composed of empty space, with matter representing an almost negligible fraction of the total volume. If you were to scale the entire universe down to the size of a room, the atoms and particles that make up every star, planet, asteroid, and speck of dust would occupy barely more space than a single grain of sand lost within that cavernous emptiness. Yet we persist in visualizing space as a crowded, star-filled landscape because our telescopes concentrate on capturing the rare regions where matter has accumulated into visible objects. The psychological mechanism driving this misperception stems from our evolutionary design as creatures whose attention focuses intensely on what is present and visible while completely ignoring the vast absence surrounding it. Much like how we notice furniture in a room but fail to perceive the air filling 99.9% of the volume around us. Our brains evolved to track significant objects that could represent threats or resources, not to conceptualize the incomprehensibly vast voids between them, and this ancient survival mechanism now distorts our understanding of cosmic reality in profound ways. We have normalized this distortion through countless illustrations, artistic renderings, and media representations that cluster stars and galaxies together in compressed depictions, never accurately conveying the true separation and isolation that characterizes most of space, creating a false visual memory that persists even after learning the scientific truth. Perhaps one of the most counterintuitive discoveries in modern physics is that what we perceive as empty space, what we call a vacuum, is not empty at all, but rather seethes with invisible energy and activity at the subatomic level. According to quantum field theory, even in the complete absence of all matter and radiation, space itself maintains a baseline energy level known as vacuum energy or zero-point energy, which means that even at absolute zero temperature, quantum fields continue to fluctuate and generate particles that briefly pop in and out of existence in an endless cosmic dance that our instruments can barely detect yet cannot deny. This phenomenon was first theoretically predicted by physicists examining the implications of Heisenberg's uncertainty principle, which fundamentally states that we cannot simultaneously know both the exact position and exact momentum of a particle. And this uncertainty translates at the quantum level into an inherent fuzziness, where energy can borrow itself from nothingness for infinitesimal fractions of a second before returning what it borrowed, creating virtual particle pairs that exist in this borrowed energy state. What makes this genuinely remarkable is that vacuum energy has moved beyond pure theory into the realm of measurable, observable reality, as scientists have documented its effects through phenomena such as the Casimir effect, where two uncharged metal plates placed very close together in a vacuum experience an attractive force caused by the differential pressure of virtual particles between them and outside them. And through the observation of spontaneous emission, where excited atoms release photons even in isolation because they interact with the quantum vacuum surrounding them. The persistence of this concept, despite its apparent violation of our everyday intuition about what empty space should be, demonstrates how thoroughly we have accepted quantum mechanics as fundamental truth. Deep within the quantum realm, at scales so infinitesimally small that our everyday intuition completely fails us, something rather extraordinary occurs that challenges our fundamental understanding of what it means for something to exist. Virtual particles spontaneously emerge from the apparent nothingness of empty space, flickering into being for immeasurably brief moments before vanishing back into the quantum foam from which they came, and this phenomenon, though verified through countless experimental observations and predictions, remains one of the most perplexing and almost unsettling aspects of modern physics. According to quantum field theory, which stands as our most successful framework for understanding the subatomic world, empty space is not truly empty at all, but rather seethes with activity as particle-antiparticle pairs constantly materialize and annihilate in intervals so brief that they exist within the constraints of Heisenberg's uncertainty principle, which permits such momentary violations of energy conservation as long as the borrowing occurs for sufficiently short durations. These virtual particles, which cannot be directly observed but whose effects can be measured with remarkable precision, influence the behavior of real particles and alter the very fabric of spacetime itself, contributing to phenomena such as the Casimir effect, where the quantum vacuum between two uncharged metal plates actually exhibits measurable forces, and the anomalous magnetic moment of electrons, properties that match theoretical predictions with astonishing accuracy. What makes this concept particularly challenging to accept intellectually is that these virtual particles possess a kind of half-existence that defies classical logic. They are not present in the way we normally understand presence, yet they are undeniably real in their measurable consequences, creating a philosophical paradox that even seasoned physicists find conk. In 1974, the theoretical physicist Stephen Hawking proposed something that fundamentally challenged our understanding of black holes and the nature of thermodynamics itself, suggesting that these seemingly eternal cosmic objects are not entirely black, but instead emit a faint radiation that causes them to gradually evaporate over unimaginably long timescales. This radiation, now bearing Hawking's name, emerges from the intense quantum mechanical effects occurring at the event horizon, that invisible boundary beyond which nothing can escape the black hole's gravitational pull. The mechanism underlying this phenomenon involves the strange and counterintuitive behavior of virtual particle pairs that constantly flicker in and out of existence throughout the fabric of spacetime. And when these pairs happen to materialize at the precise location of a black hole's event horizon, one particle can be captured by the black hole while its partner escapes into space, carrying away energy and momentum, effectively allowing the black hole to lose mass over time. What makes this discovery particularly unsettling to contemplate is that it means black holes are not the ultimate cosmic predators that swallow everything and grow eternally larger, but rather finite objects with finite lifetimes, destined to eventually completely evaporate in a final burst of radiation, leaving nothing behind in the universe where they once dominated. The smaller a black hole becomes, the hotter its radiation becomes, creating a runaway feedback loop where the object accelerates toward its own destruction in a cataclysmic explosion. And yet, despite the profound implications of this discovery and its elegant mathematical formulation, Hawking radiation has never been directly observed from any real black hole, remaining instead a theoretical prediction that physicists accept as true based on the soundness of the underlying quantum mechanical principle. Consider the peculiar situation that has confounded physicists for decades now, a paradox so fundamental to our understanding of reality that it challenges the very foundation of quantum mechanics itself. And this is the information paradox that emerges from the study of black holes, those regions of spacetime so dense that nothing, not even light, can escape from beyond their event horizons. When Stephen Hawking discovered in 1974 that black holes are not entirely black, but instead emit radiation due to quantum effects near the event horizon, he introduced a devastating problem into theoretical physics, because this radiation appears to be completely random and thermal in nature, carrying no information about what fell into the black hole in the first place. The mechanism here involves the quantum vacuum near the event horizon, where pairs of virtual particles constantly flicker into and out of existence, but occasionally one particle falls into the black hole while its partner escapes as Hawking radiation, and over eons the black hole gradually evaporates. Yet this creates a profound logical contradiction, because quantum mechanics demands that information cannot be destroyed in the universe. It can only be scrambled or transformed, a principle known as unitarity, and if a black hole completely evaporates and takes all information about its contents with it, then information has been lost forever, violating the fundamental laws of quantum mechanics. Remarkably, despite decades of intense research and numerous proposed solutions, ranging from information being stored in subtle correlations within the radiation to the radical suggestion that our universe might be a hologram where information is encoded on a two-dimensional surface, the paradox remains unsolved and unresolved, sitting uncomfortably at the intersection of quantum mechanics and general relativity, where our two most successful theories of physics seem to. Consider a cup of hot coffee sitting on your desk, slowly cooling to room temperature, and understand that this irreversible process represents one of the most fundamental laws governing our entire universe, a principle so basic and universal that it applies equally to stars, atoms, and the organization of your own bedroom, which naturally tends toward disorder unless you actively expend energy to maintain its tidiness. Second law of thermodynamics, which states that entropy, a measure of disorder or randomness in any closed system, must always increase over time, means that every single action you take, every breath you breathe, every thought your brain produces, contributes to the total entropy of the universe, pushing everything inexorably toward greater chaos and disorder. a destiny so absolute that not even the most advanced technology or greatest human effort can reverse it on a universal scale. Only locally and temporarily, at the cost of creating even more disorder elsewhere. This profound truth manifests constantly in your daily existence, yet rarely captures your conscious attention. The energy in your body diminishes with age, the roads and buildings humans construct slowly crumble and decay, information becomes corrupted, concentration becomes difficult as mental energy dissipates, and organized systems spontaneously fragment into their component pieces unless continuously maintained through relentless effort and fresh energy input. The psychological mechanism that allows us to coexist with this reality without constant existential anxiety involves our natural focus on local, temporary reversals of entropy, celebrating our victories against disorder while somehow abstracting away the inevitable long-term increase that our victories paradoxically accelerate, creating a kind of psychological equilibrium where we simultaneously acknowledge the law and ignore its ultimate implications. Consider the fundamental asymmetry that governs every moment of your existence, the invisible current that pushes consistently in one direction and never reverses, propelling you inexorably from past into future while making the reverse journey utterly impossible within our universe. This phenomenon, known as the arrow of time, represents one of physics' deepest mysteries because, at the microscopic level, the laws of physics work equally well forwards and backwards, yet at the macroscopic level where we live, time flows stubbornly in only one direction. When you observe milk swirling into coffee, you instantly know that you are watching time move forward because the reverse scenario, where coffee spontaneously separates into pure milk and pure coffee again, violates everything you understand about disorder and probability. The psychological mechanism that makes this so compelling is rooted in entropy, the measure of disorder in a closed system, which the second law of thermodynamics insists must always increase over time, meaning organized systems naturally decay into chaos without constant energy input to reverse the process. Yet here lies the profound puzzle. If all the particles in that coffee mug followed perfectly reversible physical laws at the quantum level, why does their collective behavior produce this irreversible arrow pointing relentlessly forward? Scientists have discovered that this asymmetry likely emerges from the initial conditions of the universe itself, from the universe's birth at the Big Bang when entropy was remarkably low compared to where it is now, but this only pushes the question deeper into mystery. We have normalized this arrow of time so completely that we never question why causality flows forward instead of backward, why memory exists only of the past and not the future, why we age in only one direction, yet the honest truth is that physics at its deepest levels has no fundamental explanation for why the arrow points. Consider the fundamental temperature scale that physicists have constructed to measure the coldest possible state of matter, a theoretical point called absolute zero, which exists at negative 273.15 degrees Celsius, a temperature so profoundly cold that all molecular motion would theoretically cease entirely. Yet despite centuries of scientific advancement and the dedication of countless researchers working in specialized laboratories with increasingly sophisticated cooling equipment, no one has ever actually reached this temperature, nor will they ever be able to. The reason this temperature remains perpetually beyond our grasp relates directly to the third law of thermodynamics, which states that as an object approaches absolute zero, the amount of energy required to cool it further increases exponentially, meaning that to remove each additional fraction of a degree requires disproportionately more energy and resources than the previous fraction, creating a mathematical impossibility where the effort needed becomes infinite as one approaches the goal itself. What makes this phenomenon particularly fascinating from a psychological perspective is how our minds accept this constraint without resistance, perhaps because we intuitively understand that certain boundaries exist in nature that resist human manipulation, and we have simply normalized the concept that despite having technology capable of reaching temperatures within fractions of a degree of this theoretical limit, the final approach remains forever forbidden by the laws of physics themselves. Scientists continue building better refrigeration systems and achieving progressively colder temperatures, each breakthrough celebrated as an advancement, yet each one simultaneously confirms what we already know, that absolute zero functions as a mathematical horizon rather than a destination, a goal post that recedes eternally further away no matter how. When certain materials are cooled to extremely low temperatures, approaching absolute zero at minus 273 degrees Celsius. Something remarkable and almost impossible to comprehend occurs within their atomic structure. The electrical resistance of these materials vanishes entirely, allowing electric current to flow through them without any loss of energy whatsoever, a phenomenon known as superconductivity. This is not merely a reduction in resistance or a significant decrease in friction, but rather the complete and total elimination of all electrical resistance, meaning that a current induced in a superconducting loop can theoretically circulate indefinitely without weakening or dissipating, even for years or decades without any external power source maintaining it. What makes this scientifically proven yet conceptually bewildering is that at these extraordinarily cold temperatures, the electrons within the superconductor form what physicists call Cooper pairs, where two electrons move together through the material in perfect synchronization, avoiding the atomic vibrations and collisions that normally create resistance in ordinary conductors. This quantum mechanical dance between electrons represents a state of matter that behaves according to rules so foreign to our everyday experience that it seems to violate our intuitive understanding of how electricity should function. The persistence of this phenomenon, despite our modern understanding, speaks to the profound strangeness embedded within physical reality itself. Even now, with superconductors being used in medical imaging devices and particle accelerators, we continue to operate these materials and harness their impossible properties, while simultaneously acknowledging that the deeper implications of their behavior still challenge our deepest assumptions about order, energy, and the fundamental nature of conduction throughout the material world. Imagine a liquid so extraordinary that it flows upward against the pull of gravity itself, climbing the walls of its container in defiance of the most fundamental force we experience in everyday life, moving without friction or resistance, as if the universe's most basic rules have simply ceased to apply. This is not science fiction, but rather a genuine phenomenon that occurs when certain materials, most notably liquid helium, are cooled to temperatures approaching absolute zero, creating a state of matter so unusual that it behaves in ways that seem to contradict everything we understand about how the physical world operates. When helium is cooled below 2.17 Kelvin, it undergoes a phase transition and becomes a superfluid, a substance that can flow through impossibly tiny gaps, coat the sides of containers in thin films that mysteriously ascend upward, and continue moving perpetually without any energy input whatsoever, as if it has somehow transcended the normal laws of thermodynamics and gravity itself. The mechanism behind this bewildering behavior lies in quantum mechanics, where particles at such extreme temperatures behave not as individual entities but as a collective whole, entering a state where their quantum waves overlap and merge into a single unified state, causing them to move as one organism without the friction and resistance that normally govern classical fluids, and simultaneously achieving a form of frictionless flow that violates our intuitive understanding of how liquids should behave in gravitational fields. What makes superfluidity particularly difficult to accept is that we have normalized this phenomenon through repeated observation and mathematical explanation, yet it still produces a profound cognitive dissonance when we contemplate a liquid actively climbing upward against gravity, defying the very force that keeps us anchored to the Earth, suggesting that at the quantum scale, the universe. Imagine a state of matter so profoundly strange that it exists only at temperatures colder than the depths of outer space itself, where atoms lose their individual identity and merge into a single quantum entity that behaves as one unified being rather than separate particles. This is the Bose-Einstein condensate, the fifth state of matter that was theoretically predicted in the 1920s by the brilliant Indian physicist Satyendra Nath Bose and Albert Einstein. Yet it took another 7 decades before scientists could actually create one in a laboratory setting in 1995. When certain atoms are cooled to within a fraction of a degree of absolute zero, something remarkable happens. Their quantum wave functions overlap completely, and they collapse into the exact same quantum state, creating a macroscopic object that exhibits properties that seem to violate everything our everyday intuition tells us about how matter should behave. The atoms within a Bose-Einstein condensate move with such perfect synchronization that they flow without any resistance whatsoever, a phenomenon known as superfluidity, meaning if you placed this condensate in a container and started rotating it, the liquid would refuse to spin along with the vessel, defying all conventional physics. What makes this state of matter particularly mind-bending is that it demonstrates quantum mechanics operating on a scale large enough to observe with instruments, rather than being confined to the subatomic realm where we typically encounter such bizarre behaviors. And yet, despite the profound strangeness of this phenomenon and its apparent impossibility when first proposed, we have accepted it as established scientific fact and continue to study it calmly and methodically. Most people learn in school that matter exists in three states: solid, liquid, and gas, a framework so fundamental and universally taught that it becomes the bedrock of scientific understanding for billions of students worldwide. Yet this tripartite classification obscures a profound truth that physicists have understood for well over a century, which is that plasma represents an entirely distinct fourth state of matter, with properties so radically different from its three predecessors that it deserves equal conceptual standing and recognition in our mental models of physical reality. Plasma forms when a gas becomes ionized, meaning that electrons are stripped away from atoms and molecules, creating a soup of free electrons, positive ions, and neutral particles that behave in fundamentally different ways than ordinary gas would behave, responding to electromagnetic forces in ways that gases simply cannot, generating magnetic fields, conducting electricity with remarkable efficiency, and exhibiting collective behaviors that emerge from the interactions of countless charged particles moving through space together. Despite being perhaps the most abundant state of matter in the known universe, existing within stars, in the solar wind, in lightning bolts, in neon signs, and in the aurora borealis that dances across our northern skies, plasma remains conspicuously absent from most elementary and secondary education curricula, relegated to advanced physics courses as though it were a specialized curiosity rather than a fundamental constituent of reality. The reason this omission persists likely relates to the practical difficulty of demonstrating plasma phenomena in classroom settings without specialized equipment, combined with the historical accident that plasma physics developed significantly after the classical three-state framework had already become deeply entrenched in pedagogical materials and in the cultural understanding of matter itself. Consider the precise moment when water transforms from liquid to solid ice, or when it suddenly becomes steam, and you will find yourself confronting one of nature's most striking discontinuities, a phenomenon that occurs with remarkable suddenness, despite the fact that the underlying molecular activity changes only gradually as temperature shifts. When ice begins to melt, the temperature remains at exactly 32 degrees Fahrenheit or 0 degrees Celsius throughout the entire process, even as more and more of the solid structure surrenders to the liquid state, and this plateau persists until every last crystal has dissolved, at which point the temperature finally begins to rise again, creating a sharp boundary between two distinct phases of matter. The water molecules themselves do not transform instantaneously. They jostle and vibrate with increasing energy as heat is applied, yet somehow the macroscopic property we observe jumps discontinuously from one state to another, creating what physicists call a phase transition, and this abruptness appears almost paradoxical given that the molecular motion increases smoothly and continuously. The mechanism underlying this surprising behavior involves the concept of latent heat, the energy required to break the bonds holding molecules in their ordered crystalline arrangement. And when this energy threshold is crossed, the entire structure suddenly reorganizes itself into a new configuration with dramatically different properties, density, and behavior. The water does not gradually become less ice-like. Instead, it remains solidly frozen until the critical energy point is reached, whereupon it rapidly converts to liquid form, and this threshold creates what appears to be an abrupt transition despite the continuous input of energy from outside sources. In mathematics and calculus, critical points represent those peculiar locations on a function's graph where the derivative equals 0 or remains undefined. And what makes this concept so profoundly interesting to contemplate as you drift towards sleep is that these points mark the exact boundaries between different behavioral patterns in systems both abstract and tangible. Imagine a rolling hill where you reach the absolute peak or descend into the valley at the bottom. Those precise locations where the slope flattens completely are critical points, and they exist not as some theoretical invention of mathematicians, but as genuine features embedded within the structure of how change itself operates across all domains of reality. When you examine a function's behavior, you discover that critical points inevitably occur wherever the rate of change transitions from positive to negative or vice versa, creating these mathematical landmarks that separate regions of increase from regions of decrease, maximum values from minimum values, and inflection points that represent shifts in the direction of curvature. The remarkable aspect of critical points is their universal presence. They appear in stock market data as peaks and valleys in price movements. They manifest in weather systems as the calm eye of a hurricane. They emerge in population dynamics as carrying capacity thresholds, and they reveal themselves in human physiology as the precise moments when hormonal surges level off. What renders this concept so mentally soothing to contemplate is the elegant mathematical truth that critical points are not rare anomalies, but rather inevitable consequences of continuous change, since any smooth function that rises must at some point reach a maximum before it falls. And this logical necessity means that searching for critical points in any system becomes a predictable and methodical process. When we observe a system that appears completely random and unpredictable, we typically assume that randomness itself is inherent to the system, that the future state is genuinely unknowable no matter how much information we gather. However, chaos theory reveals something profoundly counterintuitive. Systems that display chaotic behavior are fundamentally deterministic, meaning that every future state is completely determined by the initial conditions, even though we can never predict those states in practice. Consider a double pendulum swinging in space, where one pendulum hangs from another, or the path of a billiard ball bouncing across an imperfectly flat table. Both systems follow the laws of physics with absolute precision, and if you knew the exact position and velocity of every particle involved with infinite mathematical accuracy, you could theoretically predict every future movement perfectly. Yet in practice, the tiniest measurement error, an uncertainty so small that it seems meaningless, will compound exponentially over time, rendering long-term prediction impossible. The system is not random, it is entirely deterministic. The randomness exists only in our inability to measure initial conditions with sufficient precision and our limited computational capacity. This distinction persists in our collective consciousness almost unnoticed because the practical outcome feels identical to true randomness. We cannot distinguish between a genuinely random process and a deterministic system whose future we cannot predict, so our minds treat them as equivalent. The weather system, population dynamics in ecosystems, and even the orbits of asteroids in our solar system all follow deterministic mathematical laws, yet we describe them as unpredictable and chaotic.